Thank you, Patrick. Thank you for joining us this morning. Good morning. This presentation will focus on the designing for bicycle safety. This is the third in a series of training workshops. The first was on complete streets, and you could find the recording on the TA's website. The second last month was for on designing for pedestrian safety, and today we will cover the design elements for bicycle safety. At this point, I would ask you to please silence your phones or any other source of background noise. As Patrick mentioned, this presentation is going to be interactive. There will be a number of questions, and so please expect to be responsive to these questions, please. And you can raise your hands if you have questions yourself at any point. The presentation itself will start by our introductions and why we're here, and we'll cover the different design elements on how we can retrofit roadways to better accommodate and establish bicycle facilities, whether through capital projects or even maintenance and resurfacing projects. The different types and classes of bike facilities, designing protected intersections to better accommodate the movements and safety of pedestrians and bicycles, the upgrades to the different traffic control devices and signal modifications, including the provision of bicycle signals, bicycle parking, and different streetscaping and furnishing elements. And towards the end of the presentation, we will cover upcoming funding opportunities for bicycle-related projects. And you can ask questions throughout. Next slide, please. So who will be giving the presentation? It will start with Joe Gilping, principal with Alta Planning and Design. And towards the end, Patrick Gilster, DTA's Manager of Programming and Monitoring, will be covering the different funding opportunities that are upcoming. I'm the Deputy Director with the TA Highway Program, and I'm joining Joe and Patrick's presentation today just to emphasize the importance of forming projects for complete streets and to establish a transportation system that's truly can accommodate multimodal. And if you could please, in the chat, indicate your name, your affiliation, and email address. I believe there are comments in the chat already, Patrick. Next slide, please. Next slide. As you know, DTA manages the Measure A and Measure W funds, and these measure funds covers highway projects, as well as improvements on local streets, grade separations, transit improvements, bicycle and pedestrian facilities, and TDM. Actually, measure funds also cover ITS planning, which can be coordinated with any types of these projects listed in front of you. Next slide, please. The primary objectives of giving this presentation is, again, to emphasize the importance of establishing a multimodal transportation system that accommodate all road users in an equitable manner, even for highway projects, let's say interchange project, how it's connected to the local street network and improvements near the interchange. Improving roadway safety conditions in general and sense of security through the best practice principles for design and operations. Increasing cycling, modal share, and the connectivity between bicycle traffic with transit and the different traffic generators and land uses. Again, towards the end of the presentation, Patrick will take you through upcoming funding opportunities because we want to develop projects that are not just competitive for measure funds, but competitive within the states and for federal funding as well. Next slide, please. Oh, I think Joe will start by asking the series of questions. So I will pass it on to you, Joe. Thank you. And thank you for joining us today.
Yeah, everybody, thank you. And thank you, Heba. Before we get going into the actual training, I wanted to just find out, and since our polls aren't working this morning due to that settings change, if you could use the reactions button at the bottom of your screen. And if you did attend either of the last two trainings that we've done, I'd love to see a show of hands go up through the reactions just to get an idea of who's been here already before. Okay, so I'm starting to see a bunch of hands go up. I'll give that a couple more seconds. I'm saying maybe about half. Maybe a little bit under half. Okay, great. Thank you, everybody. So that helps me a little bit. We're not going to see a whole lot of repetition in this training versus the last two, but we did have a higher level training on sort of an introduction to complete streets, a lot of the concepts that we've been talking about. And that one was really primarily aimed more at sort of high level elected officials and other types of folks associated with the different communities throughout San Mateo County. Then we had our pedestrian training, which was very data specific. We were talking a lot about crash reduction factors, crash modification factors, the evidence that's out there to tell us what types of crossing treatments are effective from that perspective. Now we're going to venture into bicycle facilities. And unfortunately, we don't have crash reduction factors, crash modification factors for nearly all of the treatments that we'll be talking about. But we do have a lot of great anecdotal evidence. We're going to show you a lot of photos as we go through here. We did send a poll around at the end of last year, trying to find out what topics were going to be the most interesting and topical for all of you and relevant to your work. And so we did take the items that were the most heavily mentioned in that poll, and we've used that to build this training around it. So hopefully you'll find it interesting. Please, as I go through this training, if you have any moments of interest or want to stop and talk about something, the chat window is available for you to ask those questions. I have it open on my screen. I can see it as it comes in. And if I somehow miss it, Patrick can jump in and grab my attention or something as we go forward. So we'll get into the bicycle training. Again, my name is Joe Gilpin. I'm a principal with Alta Planning and Design, and I've got about 20 years of experience designing bicycle facilities around the country. So not just in California, but all over the place. And it's been kind of neat because I've been able to see things go from the way things really used to be to the way they are now, and being able to have some level of insight into the way that they're moving. And so I'm hoping I can convey a lot of that to all of you today. And share with you a lot of my experience going through designing a lot of these projects, and definitely key things that I've learned through the design process and things that I can pass on to all of you as you begin to study this stuff and to integrate more types of bicycle facilities into your projects. So the things that were considered here really are two things. One is safety, and the other one is comfort. And I'll start with safety. And we did show this graphic in the Complete Streets training, but it does look at 5 years of crash data throughout the county. And this is 2014 to 18, and there were almost 1,200 bicycle involved collisions that resulted in 9 fatalities and over 1,200 injuries. So it is a a substantial problem. Some other data that came out of this that was interesting was about 10% of those collisions resulted in a fatal or a life-altering injury, so something very serious. Only about 17% occurred on state highways, so Caltrans facilities. So a lot of these are happening on our city roadways out there. And the three main causes, totaling almost 60% of those crashes, were drivers not yielding, drivers improperly turning across the path of the bicyclist. So we're going to have a lot of slides that are going to talk about different paths of travel of both users and what we can do to manage and control those behaviors to make things a little bit more safe. And then the final thing is speed. And we've really talked about speed throughout the series of trainings. And if we can get lower speeds, we're going to achieve conditions whereby we hopefully have more time to avoid and prevent crashes from happening. And if they do happen, we're traveling more slowly so that they are less severe when they do happen. So those are the key things that we'll be covering from a crash perspective. So again, I don't have amazing amounts of national level data to share with you. I do have a lot of local anecdotal stuff and just things that we've learned, but basically some things that we've learned over the last decade of designing higher quality bicycle facilities is that we found that there is safety in numbers. Every city that's expanded their network rapidly has seen a per capita reduction in bicycle crashes and injuries and fatalities, which has been really great. We've also seen, on a huge spectrum, if you build facilities that they get used, and what we've really learned is if you build comfortable, high quality facilities, they get used in droves. And so there's a difference between putting something on the ground and putting something that's going to be really comfortable and very highly usable for everybody. The other thing we're finding is the more stuff or space that you can put between people that are walking and bicycling and moving traffic, especially higher speed, higher volume traffic, the more types of people that are going to use that. And I'll share some data with you there. And then the details matter. That's another huge thing that's come out of this. There's been studies that have shown at a very high level, oh my gosh, this is causing crashes. And you begin to look at it and you say, and you begin to realize some of these facilities do cause more crashes because they're very poorly designed. And some of them have lower rates of crashes because they're well designed. And so what can we pull out of that? Again, we don't have specific crash modification factor type data, but we do have a lot of experience that's been gained on what works and what doesn't from a design perspective. So I'll try to convey all of that as we go through. Now, the concept of bicycle facilities has evolved a lot, as I've mentioned, and over my own career over the last 21 or 22 years or so. And when I began in the industry, we really had this one AASHTO guide for the development of bike facilities, and things were very split between doing very minimal bicycle lane type facilities, class 2s, and just telling the bicyclists that you need to get educated, you need to understand how to share the road, and you need to share the travel lane with motor vehicles. And that was the way things were. And that's the way I learned how to ride bikes. And I grew up riding in San Diego and the Central Coast. And that's the way I did ride bikes. And I was trained, it worked very well for me, but again, began to realize that there weren't a lot of me's around. And when more higher quality facilities started coming out, I began to see a larger diversity of people riding bicycles, of different ability levels, of different ages being out there, and you begin to really see the connection between facilities that are sensitive to all of these different types of comfort and sensitivities to traffic stress, and just these strong and fearless riders that I used to consider myself. I'm now a lot older and a little bit more traffic adverse, risk adverse than I used to be when I was in my 20s. So those are all things that I'm thinking about too. So over this time, we've seen a huge progression in bicycle facilities, way more so than in pedestrian facility design. Cities began to realize that they didn't have the toolkits that they needed to build these facilities that people wanted. And so they began to create their own. And cities like San Francisco, Chicago, LA, New York City began to experiment and create things that we call these separated bicycle lanes, these class 4s that we now know them as, and intersection treatments and different types of signaling information. All of these different tools that we've seen evolve over time, and that experience has been gained. And as this has happened, we've seen a huge number of new design guidance documents, everything coming out from NACDO, different design guidance coming out from FHWA that's not part of the METCD process. We've seen interim approvals get released since the 2009 METCD. So all of this has been moving very quickly. And I was the project manager for the original NACDO Urban Bikeway Design Guide back in 2010. And when we put that together, it was so far out there in terms of what FHWA and the METCD had in there that it was a little bit hard to get people to buy into a lot of the concepts. I can say confidently that today, a little over 10 years or 12 years later from that issue and date, almost nothing in that original NACTO guide is now not acceptable to do at a wide scale anywhere in the country. And a lot of those treatments have been blessed by FHWA through the interim approval process. And as I say this, we're moving towards kind of a new paradigm in bicycle design guidance. So the METCD is under update, the AASHTO guide for the development of bicycle facilities is under update, and we've been waiting for that on bated breath for several years now at this point. I don't know when it's coming out, but it will hopefully really contain, nearly everything that we've learned over the last decade in doing that, and it will be a great kind of one-stop shop design guide for that. The NACTO guide, even the one that we were involved in 10 years ago, is now beginning an update. And right now, I had a call with NACTO a week ago, and they're trying to figure out, because the AASHTO guide is still not out yet, they're trying to figure out where their place is here. They want to supplement and give more relevant contextual guidance, but not sort of repeat what's going to be in AASHTO either. So there's this really neat synergy that's developing. You have a toolkit that was put in the CCAG Comprehensive Bicycle and Pedestrian Plan also that has a lot of informational resources in there, but we're very close to having what I'm considering kind of a new paradigm in design guidance. And the California METCD, I did want to point out, is ahead of the national METCD on a lot of these cases, and I'll point out some of those as well as we go through. Now, in terms of comfort, we've learned a lot over the last 10 to 15 years, and we've learned that people aren't all the same in terms of their traffic tolerance and what types of facilities will motivate them to ride bikes. And what we found is that back in the day that we really serviced these highly confident riders, shared travel lanes, bicycle lanes with nothing else on them on the high volume, high speed roadways, people like me. And people like me make up a very small percentage of the population. And so as a result, very few people were riding bikes on a high level. We found that as we do more class 1s, as we do more class 3 type bicycle boulevards and class 4 separated bike lanes, we begin to unlock these other layers of the population. And these are people that may not identify as bicyclists. They're just normal everyday citizens, but they want to be able to use their bicycle for some types of transportation work, riding, some types of recreation, potentially to get to school, to get to work, to get to the doctor's office, to get groceries, all of these different types of trips that can be part of this overall transportation network. And we found that as you begin to add more comfort, you begin to unlock this next phase, this somewhat confident rider. And then even more so, you get to this really amazing level of potential. And this is who we call the interested but concerned. These are people that say, I would love to ride my bike more, but I'm not comfortable with the current status quo of the built environment. I need facility types that are going to make me feel more comfortable in terms of going out there and getting on my bicycle. So these are the sweet spot. These are the folks that if we can create infrastructure that makes them comfortable, we're going to see a lot more people using this type of transportation out there on our network. So let me go into real quick a basis of how we kind of measure what our network is. And this is what we call level of traffic stress analysis. This is a replacement for the bicycle level of service type modeling that's been out there in the past, which basically says that if you have a wide shoulder, that's LOSA, you couldn't do any better, which isn't really the truth. We know we can do better than just having a wide shoulder on a roadway. So the bicycle level traffic stress model gets into how the road feels. It's a little bit more qualitative, but it's based on quantitative data. But it's really easy data that we have. We have speed limit data, we have volume information, we have number of lanes, we have presence of bike facilities, the widths, all of these different types of things we have generally within our publicly available GIS. And so we can run this model pretty easily. And what we find is that we can categorize streets in 4 levels. Are they really comfortable? Are they really suitable for what we consider all ages and abilities? So this would be everyone from 8 to 80. So kids on smaller kids, children on bicycles, all the way up to people that are advanced in age. Are they all tolerable and able to be used? And so a class 1 type facility might fit that bill, or a neighborhood street that has low volume and low speed. If you look at a neighborhood street, you'll see kids riding their bikes a lot of times on that type of facility. So that does make sense. And then we get into LTS2, comfortable for Main Street adults, and then acceptable for the enthused and confident. We're starting to lose a little bit of our comfort as we get down here. And so maybe a bicycle lane on a collector that doesn't have a lot of extra stuff would still be LTS3. And then on our main arterials, we have a lot more discomfort that's experienced in those areas. And so we need more. We need a separated class 1 or a class 4 maybe to be able to provide greater comfort, but that still may not be all ages and abilities depending on how it's designed. So there's a lot of things that we've learned. And very interestingly enough, all of you will have this analysis already done. So this is part of that comprehensive bicycle master plan that's been put out there. And if you get into the appendices, you'll find an LTS map for every single city and incorporated area within San Mateo County. So here's a couple of examples from that. And a couple of things that are immediately obvious to me that are pointing out from these, and this is very common throughout the country, is that you have these large islands of comfortable roadways. These are our neighborhood streets. This is where we walk our dogs and ride bikes around the area, and the kids are playing. But they're separated. They're islanded by these higher speed discomfort. It could be railroad tracks. It could be a creek. It could be a freeway. It could be an arterial, a barrier that's confining you from being able to get out of your comfortable island of roadways and to be able to get to destinations around the community. So then the question becomes, okay, well, how can we use this analysis to actually create solutions? And there's two ways we can look at that. One is solutions that overcome the connectivity problem. How can we get across this barrier that's saying this is very uncomfortable? And from what we've been able to find out from a lot of the studies that we've done is that people, when it gets up to a 5-lane roadway, very few people are comfortable crossing that. And you have to do a lot to be able to make that a comfortable crossing. So for example, here's a project, I believe, in Palo Alto that's going over a major roadway here. And then also, can we do something to the route itself to make that route more comfortable and turn it from a red route into an orange or a light green route in terms of its connectivity? And once you begin to make some of these leaps, these barrier breaking projects, and then also corridor projects, you begin to turn more of that roadway infrastructure into a comfortable network that can actually deliver people from their homes to these destinations that they want to get to. And a lot of how we think about this gets into really how we think about comfort. And I like to create this parallel with motor vehicles. And, we don't design our roadway infrastructure around the physical size of a single human, right? We don't have these single passenger cars that literally have their doors right at your shoulder on both sides. This would be kind of a weird thing if we did, but that's exactly how we do it for bikes. Even in cars, we're social. So here for bicyclists, this is the way that we design for our facilities. So sidewalks, we design them typically for 2 people walking side by side. A car, we design that for multiple people. We're able to be social. But our bicycle infrastructure hasn't been, and it's one of the only, in fact, it's illegal to ride side by side in a lot of communities around this country because of the width that takes up. And so you can only overtake or ride single file, which means you can't talk to the person that you're going with, which creates a real change in the level of experience. But we're learning that width is important, and providing places where you can have those experiences, have family outings, go places with friends, and be able to have that kind of conversational journey along the way and still allow people to be able to overtake you is important. So what does that mean? That means that the width that we've been putting in a lot of our facilities in the past hasn't been enough. And that single person methodology, that minimum design that we've been pulling out of the METCD and AASHTO, which says that we need 4 feet, that's what we need for bikes. It's really not enough. It's enough to accommodate a single person, but it's not enough to create a system that's going to be more comfortable. And so what do we need? Well, if we put 2 people side by side and we kind of overlap some of their shy distance, we come out with about 7 feet. So if you're going to design a bicycle lane that you want a lot of people to be able to use, and especially when we're talking about electric bikes, we're talking about scooters, we're talking about all of these new types of devices that you're all seeing out on the streets of your communities, we need that width to be able to mix those users together in those types of bicycle facilities. So keep that in mind. And then continuing this logic, if we want to go a little further, here's 2 people riding side by side and a third passing. Well, this is the kind of the width that you'll see on a class 1 now. California was, I think, short-sighted for a long time. We had 8 feet as the minimum for a class 1, and so many class 1s are built at 8 feet. And anyone that's ever been on one knows that they are not comfortable really, because they're congested. They're very difficult to maneuver. There just isn't enough space to do that. So we want 10 feet typically as a minimum, and in some cases even larger. We're seeing some of these regional class 1s that are being created at 14 feet, in some cases even larger, because of the types of flows, the density of use, the mixes of use between different types of users on those facilities. That's all important to get this extra width. So I'm gonna focus on this width as we go through the rest of this training. So let's talk about where we find the space to make more space for people walking and bicycling, and particularly bicycling here. And the two types of projects that we typically come into are major reconstructions, which are infrequent in number. They happen on a very long timeline. They're very expensive. So we want to make sure that if we're doing this, we're doing it right. But we're not going to get the network we need fast enough just through reconstruction. So that means that we have to also bring in retrofits. And so retrofits, to me, are, in some cases, they can be triggered at any point, but a lot of times we tend to coordinate our resurfacing with our pavement preservation activities with the ability to retrofit. And so that means that we need to carefully work with our maintenance departments, have planning, engineering, public works, all talking together throughout the stages of our day-to-day activities through our communities. So those are things that we'll talk more about. And it really, when we're doing those resurfacing projects or those retrofit projects, how are we going to find that space? And so I'm wondering, just in the chat window, if any of you have any thoughts on what ways that you could kind of look at that roadway, how it's functioning, and think about where we could find additional inside the curb, inside the existing sidewalks, space to create wider or new bicycle facilities through those types of processes. I've got the chat window open. I can see what's coming in. Does anyone have any thoughts on the three, or there's three things that I'm thinking of, but maybe you have more that you've had experience with. So Hannah's saying narrow travel lanes, Joel's saying lane width reductions in road diets, and Nicolette is saying removing parking. And the three of you have hit all three of the things that generally are what we look at. There could be additional things in here. I'm going to show you a lot of different permutations. They are by no means the only type of a permutation. Yep, Karen, one-way streets is a huge one. How are you looking at your capacity? So I look at capacity. I look at parking utilization. I'm looking at the size of my intersections and how they're being controlled, and are they driving the need for more lanes because we're not using the roadway as efficiently as possible. So there's a lot of efficiency that we're thinking about when we're thinking about trying to find more space to serve all user types. And a lot of the projects that we do work on, we may be able to even maintain our level of service goals for cars at the same time that we're able to do more for people walking and biking. So there's the lane narrowing. Obviously we're taking lanes that might be a little bit too wide, and I've measured some 12 to 13, 14 foot wide lanes in a lot of areas around San Mateo County. So I know that they're out there. We can sometimes skinny those up to 11s or even 10s in a lot of cases and find space to provide bike lanes, or even buffered bike lanes in some cases. We could be looking at lane reductions, and that could be very seldomly have I seen this, but I have seen it done in some cases, taking a center turn lane and turning that into bike lanes. It could be taking a roadway that's really just overbuilt. It has extra capacity. It doesn't need it at all times, or maybe we can take a 5-lane road with large intersections and turn it into a 3-lane road with roundabouts, and that flow, because you're not wasting all that capacity at the intersection, can still serve those users. So now we can get buffered bike lanes or class 2s or class 4s in this way. Also, we could think about parking utilization, and I see this a lot of times on narrow streets, and people don't want to park on the street because they're worried about that friction of overtaking vehicles. Are their side mirrors going to get taken off? Is there anyone that's going to hit their car? And so we can look at the parking utilization and sometimes figure out where extra parking capacity might exist, do a parking study, figure out, hey, we can take off maybe 1 lane. And I've seen projects where after this goes in, more people park on the street than before because we now have this nice buffer. And as long as that's residential parking for the most part, longer turnover, works very well with bike lanes. And then, parking from one side of the street, oops, just jumped forward. But so all those are different ways that we can look at things, and they're simplistic. We could also look at widening sidewalks. We could look at different types of intersection treatments. There's all types of things that we can do with that. But if you're interested in trying to improve your resurfacing coordination and leveraging all of these opportunities that happen every single year, FHWA has a really great guide on kind of looking at best practice and how to work with your, connect these dots between your planning, your maintenance, and your engineering, to make sure that when we put things back, we're not putting them back right the way they were. We're thinking about it, and we're doing things thoughtfully and putting them back in a way that's going to serve the public and the community in different ways, and really using that space that's available. So here's a couple of examples, and this one on the left looks pretty good. I don't know how wide these roadways, these lanes are, but maybe this could be a buffer a little bit more. But here, I see this a lot. A road diet's gone in, or maybe something's changed and there's just this extra space. And could this have been used in a different way to provide buffers or separation, or maybe even have enough space to put the bike lane at the curb and float the parking and have a class 4. So those are all things that I'm looking at, and I see this, over and over again, and in different communities as we look around. And is it just bike lanes, or can we do more things with a retrofit type project? And yeah, we can put, simple paint and traffic markings and signage down, but we can also apply color and surface treatments and put planters and barriers and all types of things out in the street in order to create some of the geometry that we're looking for that we might not be able to do as a permanent or long-term project. There's a lot of elements that we can use in terms of quick build, in terms of our resurfacing and retrofit type project works that allow us to do that. So I'll give you an example, and this comes from the NACDO Urban Street Design Guide, but it's showing sort of a normal street. And maybe you want to add a class 4 bike lane, and maybe this shows a bus lane. That's kind of irrelevant to the example, but hey, we want to use this space. So this is all just surface treatments and bollards, and they haven't done anything to the curb lines, to the drainage. Nothing's really changed here. And if you come back then and you learn how it works, you study it, you figure out some optimizations, and then when you kind of have the opportunity many years down the road to come back and actually reconstruct the roadway, how to do it at that point, and you can make those permanent changes that go along with it. So some examples from local, and again, I'm trying to draw from examples in San Mateo County if I can. If I can't, I'm going wider Bay Area, and if I can't find it there, I'm going California, and if I can't find it anywhere in California, or I'm supplementing with some good ideas from around the country, that's kind of how you'll see the pictures in this training. So here's San Jose, a lot of the kind of protected infrastructure and protected intersections that they've done. This is all done as just pavement projects, no curb line changes here, no gutter changes, nothing like that. So Karen is asking, what is the sense about getting grant funding to improve previously installed but soon to be substandard bicycle facilities when having to compete with new installation projects? I find that it's easier to improve things that didn't involve poured concrete. I definitely see a hesitation to overwrite things that have an environmental cost or a substantial investment in federal funding, for example, or state funding. But if it's local funding, or if it was just done and it's unsafe, those would be potentially things that I would see as being good cases to make. But substandard is sort of an interesting word. I would say maybe not keeping with best practice, or could be more comfortable, for example, and we'll show some examples of that as we go through. But hopefully that sort of addresses the question. It might not have fully. Here's an example from Oakland, where they actually removed a travel lane, and on a number of intersections throughout there, they created these kind of quick build protected intersections, and we'll talk more about protected intersections in a later phase of this, but interesting examples and findings that they've been finding, some good performance here in terms of conflicts and close calls that they've seen in their after type treatments. And then, in some cases, you can come back and actually narrow the roadway further, put in streetscape configurations like the Santa Monica example, and actually narrow up the roadway for other uses in doing that. And then this next one is kind of a fun one. This was a project one of our staff was involved in Salt Lake City. And this was a kind of a fun demonstration projects to create a protected type intersection. And for those of you who haven't been to Salt Lake City, they got really wide roads and not a ton of volume. So it actually is a really fun place to do roadway projects, because it's a blank canvas in some ways. Joel is asking, would like to know how we can get past concerns about maintenance associated with plastic delineators so that we can install more class 4s and protected intersections. Joel, let's come back to that. I've got a whole segment on barrier types, which we can, so if I forget, just ping me when we get there, and I'll make sure we talk about that question when we get there. But thank you for the question. Here's another example. I believe this is Memphis, Tennessee, of just using that space. And again, this space is not just mid-block. It could be space that you don't need at intersections. And we talked in the pedestrian training, hey, if we can tighten up corners, if we can get cars to turn more slowly, they're going to be more likely to yield to people walking and in this case, people crossing in the bicycle lane. So we have some options there. So rather than having a wide, really fast slip lane, maybe we can redesign this to have a slower, more controlled right turn onto the adjacent intersections. And Fremont's been doing a lot of that work in their community. So let's talk about class 2s. And I'm not going to tell you how to design a class 2. What I am going to talk about is ways that we've learned to enhance them, things that you can be thinking about when you are considering class 2s that will make them better and do more than just accommodate that kind of 4 to 5% of the population that class 2s typically sort of resonate with. So the takeaways here are, again, go beyond the minimums. We want them to be wide. And we also want to think about how we're using that width. Is this real width that everyone can use, or is this just width on some plans? And I'll come back to what that means. Thinking about maximizing separation, can we provide a buffered class 2 if we narrow up some additional lanes? And then how we can enhance a class 2 in other cases. So I'll give some examples on this. Now remember our minimums, and this comes from the AASHTO guide for the development of bike facilities, and it basically says that we're, our handlebars are 30 inches wide, our minimum, operating space is 4 feet essentially, and our preferred is 5 feet. So that 4 and 5 feet that comes out of this essentially becomes what's in the guide for a bicycle lane. And this is the graphic from the AASHTO guide. It says minimum on one side right here, which is unfortunate. It's hard to pull those minimums and make them really obvious that this is a minimum. This is not what we're asking folks to design to. And then how we think about the context of the bike lane. So here on the right, we've got a shoulder type bike lane. There's no curb and gutter. It is saying it's okay if you have 4 feet of asphalt here. But on the other side, we do have curb and gutter, and it's saying if you have that, you need a minimum of 5 feet because of the shy distance that's associated with that gutter pan. But all gutter pans are not created equal. And what does that actually do to the bicycle lane itself? So here's an example. I forget what city this is in, but it's in California. I believe it's in the Bay Area. And we have a 2-foot gutter pan and a 3-foot outside bike lane. And so this would be compliant according to AASHTO, but we have even according to California MTCD, but we have this vertical longitudinal seam that's right down the middle of this bike lane, and we have a small amount of asphalt to ride on. So this means that bicyclists aren't going to be able to take advantage of the full width of the bike lane. They're going to be kind of over more towards the moving vehicles, which makes them less comfortable. So this is a really narrow feeling facility, even though it has the minimum width according to AASHTO. And so what I believe NACTO and the AASHTO guide are going to say in the future is that, hey, you want at least 4 feet of rideable surface as part of the bike lane. So there's a minimum overall width, but there's also a minimum width of rideable surface that you need to be thinking about. And again, that's a minimum, that's not a maximum. So some examples of what that looks like. Here's an example that has a 1-foot gutter pan and a 5-foot rideable surface. I've seen in some cities, they've actually put a second white line right next to the gutter, and they don't count it. They're not allowed to count that in their width of the bike lane. The bike lane has to be an entirely rideable surface, which makes it a lot wider and more comfortable for people to use. So here's a 5+1 type bike lane. Here's in the Northeast, really fascinating. If you ever work up there or from there, you know that they don't use gutter pans. So everything's asphalt right up to granite curb. And you talk to people out west and they literally smoke will pour out of their ears and their eyes will turn red, and they don't understand how you could get away with not having a gutter pan. Well, there's entire parts of this country, including entire DOTs, that do not use gutter pans on their highways, which is interesting. So here's an example of one that's not having that extra problem with the gutter pan, so 5 feet here. And then on the opposite side of the spectrum, and I actually commuted over this bike lane for a number of years, and this is in San Luis Obispo, and this has a 4-foot widened gutter pan. So they widened the gutter pan out to provide that surface for people to ride on. I think it should have been maybe a little bit wider, but little bit of discomfort from just all the joints that you kind of have to ride over in this, but it was an effective way to make the bike lane a little bit more usable. So those are things to be thinking about. And another thing to be thinking about is, okay, maybe we've got a 6-foot bike lane, and that should be like, hey, we've done our job, we've got to the end of where we are. But how can we think about this overall space that we're looking at? Now, if each vehicle here, the bicyclist and this bus in this case, are traveling in the center of their lane, we've got less than 3 feet of kind of clearance between the two, which is kind of on the edge of really not being all that comfortable. So we've got this space, we've got 18 feet of combined space. So what if we went down to 5 feet with a bike lane, but we put a buffer in, a 2-foot buffer? Well, we've just increased the passing distance. So we've made this theoretically more comfortable, and we've provided more striping, more visual difference between those two facilities, and we've made it a little bit more comfortable. Now I'm going to get crazy here. I'm going to go down to 10 also and get to a 5+3 here, because you might say that that's too narrow for a bus lane. A colleague of mine in Carlsbad, California, pulled together a 9.5-foot travel lane next to a bike lane. And when the mirror overhangs into a buffer, it's really not the same as having the mirror being next to another vehicle lane in that way. So this could also be a way that we look at how we spend that limited amount of road space that we've got when we're going through the design process, particularly in the retrofits. So here's a few examples of buffered bike lanes, buffered class 2s out in the real world in California. So here's a travel lane side buffer. Here is a parking lane side buffer. And I'm curious, through a show of hands here, which one you would be more, if you could do one or the other, if you could spend your buffer on either the travel lane side or the parking lane side, which would you prefer as a bicyclist? So raise your hand if you would do the travel lane buffer, and keep your hand down if you would prefer the parking side buffer. I'll try to do a little census here. Karen, you're getting ahead of me here. Okay, I'm seeing a bunch of hands come in. Got 1, 2, 3, 4, 5, 6. So about 14 out of about 30. So it's about half are saying that you would prefer to have the travel lane side buffer. And I'm going to assume that the other half of you are good with the parking side buffer. And this is an interesting question, because if you talk to an experienced bicyclist, most of those folks will have some sense that they're more worried about the parking door zone, that door opening in front of the bike lane, than they are about moving traffic, because they might have some sense that getting hit from behind is actually a pretty rare occurrence when you have a bike lane from overtaking traffic. Doesn't mean that it's uncomfortable, but it is a fairly low number of our crashes that are happening. And you can see that the gentleman on the left here is actually riding, even using the buffered area to be a little bit further away from the parked car, so that individual sort of has some sense of where that real danger might happen. But danger, as we're going to talk about a lot in this training, doesn't necessarily, or risk doesn't correlate to comfort in some cases. You can have something that might feel comfortable, but still be maybe a little bit more risky, versus something that might be less risky, but more comfortable. So there's a lot of different ways to look at that. And so we'll show some of the ways that we can balance that in some cases. But Karen asked, can you do both? And ideally, yes, you would. But this obviously takes a lot more space, and we may not have this space in all cases to do that. So, again, things that I would be looking at in this scenario, I would be looking at what type of parking is it? Is this high turnover downtown type parking, or is it low turnover, once or twice a day type parking, which would be less threatening? And I would probably spend my buffer on the travel lane side in those cases. So, and there are a lot of projects that will actually swap the buffer from side to side, depending on the context of what's going on. And so maybe you come into a central business district or a commercial parking area where you have a lot of turnover, and maybe the buffer switches from travel lane to parking side through there, and then returns to travel lane on the other side. So there's a lot of ways that we can look at that. But if we have a whole lane that we can get back in some cases, and this has been done in a lot of projects throughout the country, try to get that buffer on both sides, because it will work better. But we've got a lot of space here, and we'll talk about what else we can do with that space in the future. But I did real quick want to just draw your attention to the California MUTCD, and this document does have currently, I believe, the only guidance on buffer design that exists in an MUTCD. So there is some information that's coming. There's been some proposed graphics for the National MUTCD. This information here is what was in the notice of proposed rulemaking for the National MUTCD, which is a little bit different than what we just saw in the California MUTCD. But this is all becoming very much more standardized, which is great, and we have a little bit more clear guidance. The NACTO guide does have some guidance on buffered bike lane design. The AASHTO guide currently sort of skims over it. It just says that a buffer is really helpful, but it doesn't really tell you how or what to do with it. All right, so other things that we can do with class 2s that go beyond just having that line of paint on the ground. It could be coloring them. And this is not Davis. I must have messed up that, that label. This is in San Mateo County here. So we can color things. We can maybe add a rumble strip in some cases, but we don't want the rumble strip in the bike lane. Maybe we can get the rumble strip on the outside of the bike lane. So if you've got a higher speed, area between built up areas, maybe this would be an area that would be helpful to put maybe a rumble strip in that buffer, just to give a little bit more protection. And then intersections. And I'm not going to cover intersections right here. We'll talk about them specifically, but a lot of times bike lanes get very uncomfortable at the intersections. And you can have the nicest class 2 or class 4 available, but if the intersection itself isn't comfortable, it's just not going to, it's going to be a weak link. And when you have a weak link, that becomes a barrier for all types of people to use it. And you will only be as good as your weakest spot along that route in terms of your adoption and usage from people using that. So a good thing to keep in mind. So Jessica's saying it also depends on the street. Okay, so has there been much research on the effectiveness of the rumble strips at keeping people out of the bike lane? I don't know of any studies that have looked at it. I know that bicyclists actually like rumble strips if they're done correctly. They all will talk your ear off if they haven't been. So maybe you've experienced that in the past, but I typically like having them because it really provides a audible warning for motorists that might be kind of drifting or have a little bit of inattentiveness, and that's going to stop them before they get too far into the area that they might actually come in conflict with a bicyclist. So I believe that they are helpful in that way. Some other quick little design considerations for class 2s. When you get to railroad tracks, make sure that these are at a tighter angle and you're not having the opportunity for a bicycle tire to get kind of caught in that flangeway gap between the rail and the crossing device. So huge thing here. There's this absolutely awful study that was done. I think it might have been Tennessee or something, where they had a video camera on this and they were experimenting with different angles and just all these people hitting the ground on the videos, but it seemed pretty obvious after a few people what you needed to do. So, but they found that about 60 degrees is where people stopped crashing regularly in terms of the angle between the railroad tracks and the bike lanes. So keep that in mind. And then if you have utilities, a lot of times our utilities tend to be on the side of the roadway because they're easier to maintain there, but they also end up right in the bike lane. And are the manholes, utility covers, are those compatible? Are they at a reasonable surface level? These devices typically have a different coefficient of friction than the rest of the pavement surface. And so if you've got a downhill or a braking zone, and these are in the bike lane, you could have people lose control of their bikes when their wheels change and they're suddenly not slowing down anymore or lock up because of going over a wet manhole lid or something, for example. So those are things to be thinking about. And then your inlets, A, they have bicycle friendly grates on them, and B, how far out do they project and what type of cross slope do they provide? So those are all things to be thinking about. And thankfully, this really has been an area where we've made a lot of progress on over the last 20 years. I remember some of these, I could literally get sucked into inlets. I remember if I tipped over riding as a kid. And now most of our inlets are really in pretty good shape overall. So hopefully those aren't problems. But that's all I'm really going to say about the class 2s. If you want to get more into the design guides that goes along with those, there's plenty of information in Caltrans chapter 100 and the AASHTO bike guide, all these other resources that are out there on class 2s. Any experience using Vibraline instead of rumble strips? I think anything that provides that tactile, it could be the hot thermoplastic applied vertical rumble instead of a ground in rumble. Those are both okay in my mind. And you can even have that be part of the white stripe. Although if it's part of the white stripe, that's now going to create something that is right on the edge of the bike lane potentially, and potentially reduce the effective width of that bike lane. And I'll mention some of those things as we get forward. So let's move ahead quickly, and I'm going to start to slow down again into our class 4 design guidance, because this was an area where we got a lot of interest in talking about more about class 4s, what they are, what are some of the design dimensions that we want to be thinking about. And I want to talk about a lot of the things that you won't find in a lot of design manuals, things that we've learned through projects that didn't function well, that we've seen that were built throughout the country, things that we've learned ourselves through implementing things and seeing how people actually use them after they were designed. Some of these things are kind of annoying usability issues. Some of them could be construed as potential safety problems. So I'm going to try to talk about those as much as possible. But again, we have good design guidance that's out there. We have the FHWA Separated Bike Lane Planning and Design Guide from 2015. We have the NACDO Urban Bikeway Design Guide. There's some ITE documents out there. I believe there's even a California specific one about Class 4s. The Caltrans publication that's out there on the technical bulletin on Class 4 design is out there too. So there is a lot of technical guidance. I think this technical guidance will continue to evolve a little bit and refine a little bit as time goes on, but these are all things that exist out there. So the general question becomes, if we have enough space to do a buffered Class 2, then we probably also have enough space to turn that into a Class 4. And what does that really mean? So again, these are the design manuals that are out there that you can use. And again, this has the design information bulletin from Caltrans, which is 89-01. A lot of good information in there. I was actually impressed with how succinct and simple that was to reference in looking at that. But the basic idea here is you got a sidewalk a lot of times, and while not often in California, a lot of times our sidewalks, we want to have something buffering pedestrians from the roadway. Well, we also want to have something buffering bicyclists from the roadway and to create that physical type of separation. So in this case, there might be something that's separating the pedestrian realm from the bike realm also, and I'll talk a little bit more about that, but there is a big debate right now in the industry around delineation. And if you have a raised bicycle lane and it's at a level surface with the sidewalk, what can delineate those two facilities against each other? And I can try to return to that as we get a little bit more topical. But some of these widths, again, how do we look at this? And one of the issues that I see sometimes is applying the Class 2 design guidance to a Class 4. And so does that become a really narrow 5-foot cattle chute where you can't pass anybody? And so you'll get a lot of bicyclists will be very resistant to the idea of a Class 4, particularly if they've experienced one that looks like this. You get in it, maybe there's a slower moving bicyclist, you can't get out of it, you can't pass that person, you're now trapped. And a lot of bicyclists don't like that feeling of being trapped. And so, but there is a way to work with those folks and get them to really enjoy and promote the project, and that becomes the type of width that we're looking at. And so again, are we designing to that single bicyclist, or are we designing to that side-by-side passing? And so do we have the width to be able to enable that? And if we do, I found that resistance tends to lower from those experienced, very vocal bicyclists that you may have seen in some cases resist a facility that might really create conditions for a lot more people to enjoy bicycling throughout the community, which is unfortunate. So I'm going to introduce this idea of effective operating space. And you're not going to find this in any of the design guidance that's out there, but really we're looking at from a single perspective. Again, from AASHTO, we need this 5 feet in order to be able to wiggle a little bit, in order to feel comfortable. But if we start putting stuff on the side of that, if we have vertical curbs, if we have longitudinal seams, if we have flex posts that are right up against that 5 feet, all of a sudden now we've got stuff that we have to avoid again. And so that's going to make that 5 feet really feel constrained. So what do we need to be able to provide that full operating width at all times? Well, we need the curbs to be far enough away from that 5 feet so that they're not in conflict, right? We don't want to hit our pedals on, we don't want to be worried about digging our pedal into a 6-inch tall curb, because you can. And so you'll shy away from that. So that would reduce the width of that bike lane if it was in that 5 feet. Similarly, if we had a flex post next to it, those tend to be at handlebar height. So we have a 30-inch wide handlebar width. We don't want to get too close to that thing, because we don't want to hit our handlebar on the flex post and create the conditions for a crash. And so then you begin to add this stuff up and you see, okay, I've got 5 feet. I've got 3/4 of a foot on one side, almost 3/4 of 1.7 or 1.8 on the other side. So it begins to look like a wider facility through there. So we do need 8 to 9 feet typically for a Class 4 that's like this. Now you could also have curbs on both sides. And again, we're moving towards, so I typically want 7 feet as a minimum for these type of cattle chute type facilities. And they're no longer cattle chutes once you hit 7 feet, because you can have that side-by-side riding, you can have the passing, and you have compatibility with different types of users, so scooters and other types of micromobility devices. Now, if you were in a really constrained area, you could get away with things like having lower curbs so that you're not going to hit your pedals on them, or having a mountable curb on one side where the bicyclist can get out of the facility if they need to, while still providing a detectable edge for somebody that might be using the sidewalk next to it. So those are other ways that we can think about in constrained areas, at least providing that width. And I might look at something like this at an intersection where we are trying to fit more stuff in, or we're more constrained, but not necessarily as a mid-block type treatment. So talked about a barrier on one side. Well, we could also raise the facility and have a mountable curb on one side. And so this might not have to be quite as wide, because the bicycle still could leave the bike lane and pass another bicyclist and re-enter if they needed to. And so this has delineation from the sidewalk. It also has delineation from the roadway. Motorists could still encroach, but the raised curb does provide a lot more disincentive to stay out of the bicycle facility in this case. So here's an example from San Carlos that shows that beveled curb edge on one side. And I think this looks sufficiently wide enough. It looks like it's at least 6.5, probably maybe 7 feet wide. And that would be a good facility design, in my opinion. You can see the raised fencing there. So you want to have a little bit of shy distance from that. And so the wide facility does provide that shy distance. So that's a good, again, a good design. Now, we had a question a little bit ago about what types of barriers can last longer. And what I found in my journey through the last decade of designing these types of facilities is that it's really easy and quick to put flex posts in to get that type of separation. But as was noted, there is a maintenance issue that goes along with those. So you are going to have a certain level of annual attrition. And the good types of these flex posts, we used to use really cheap delineators. In some cases, they'd be, $40-50 a piece. Some of the better ones now are pushing $150 to $200 a piece. And so now it begins to be a lot more expensive if you have to replace more of these on an annual basis. So some projects have reduced the number of flex posts that are out there. Sometimes they'll only put them in areas where they really do need that protection. What we found is that if you add up, several years of maintenance, it doesn't take too long to get to the point where if you had just put in some type of physical infrastructure like a curb or a median, you could have paid for that at some point just through the added kind of O&M cost on the backside of things. So that is definitely something to be thinking about. Now, I've broken this slide into retrofit versus reconstruction. So when you're doing a retrofit, oftentimes you're keeping the curb where it is. You're probably not going to be digging into the concrete or asphalt. Everything that you're using as a barrier is surface applied. So we're talking about using kind of a lane of parking sometimes for that, but you need good compliance from the parked cars. The flex post, you could use a higher order flex post like a K71, which is a thicker type bollard. Modular curbs, they can be pinned in, they can be keyholed in, they can be poured in place, they can be precast. There's a lot of different types that go along with that. And we've used those in a number of different ways. So Matthew's asking, how do we approach the clear recovery zone next to the travel lane? So that's an interesting concept. The clear recovery zone is a very, shall I say, strong level of opinion on a lot of different types of engineers that think about that. Now, what FHWA actually says is that if you have an urban roadway, even on an NHS route under 40 miles an hour, they do not require any type of object. So they actually removed this from their 13 controlling criteria back in 2016 for your design criteria on highways, essentially. So if it works for a highway, it's going to work for a city. Now, there's still a lot of local agencies and states that still have clear recovery zone requirements that contradict kind of what FHWA is saying, that you don't have to have them. Clearly, if you don't have things to hit, you're going to not hit them as a vehicle. And so that's one thing to be considering. The other side of things to consider are a lot of those objects that you can hit provide a lot of friction and slow traffic and potentially remove some of the conditions for those crashes to occur in the first place. I've also had testimony, I can't remember if it was from this group actually last time when we did the pedestrian training, it might've been from a recent FHWA training I did too, but somebody told a story of how they were able to hide behind something in a clear recovery zone. It was a pole or a tree or something like that, and that stopped an errant vehicle from hitting them. And so, there's different ways to look at that. I looked into lower speed clear recovery zone research, and what I found was very inconclusive from a national standpoint. A lot of the guidance that's out there seems to have been just given a number without actually showing that it's effective at low speeds. And so thinking about the type of roadway that you're on and the speed that you're expecting can influence whether or not that's within the clear recovery zone. I think FHWA and AASHTO say like 1.5 feet to 2 feet is kind of on a lower level street, plenty for what they consider, objects not being in that space. So that can be compatible with providing a lot of these barriers for bikeways. This picture here was part of an experiment that we did in Fort Collins, Colorado. I don't know if you can see my mouse, but it's the third from the left, and it has this concrete poured in place curb that we used. And we used a number of different types of treatments on this facility. It was kind of a living laboratory to look at how things worked. It was a part of a lane reduction project, and that also used that space to widen the bike facility. And so the bike facility got up to like 7 to 10 feet wide in a lot of cases and became a very comfortable roadway. And so we found was that when we did this, we reduced our vehicle, pedestrian, vehicle, bicycle crashes down almost to nothing, but we did have some slightly more fixed object crashes but very few of those fixed object crashes were substantial. They were a lot of times just minor property damage type crashes. So we made the roadway safer overall, but we did see an increase in fixed object crashes. So take that with a grain of salt or however you will. So it's not a clear answer. It is local preference in a lot of cases, but it's not necessarily required at that level from the federal standpoint. You may have standards that are on the local level that say you need, I've seen 7 feet minimum, 10 feet minimum, even on local streets in some cases. We have a project that we're working on now where we're taking away a lane of parking to provide this shared use path, side path, class 1. And the city's saying we can't put trees in the buffer, even though we've got 6 feet of buffer because it's within their 7-foot clear zone. So, and this is on a 20-mile-an-hour roadway. That's that city. So I can't get too far into that beyond that. So it's approachable. I don't believe that the crash data supports at low speeds significant problems with clear zones. All right, so reconstructions, obviously we can do more. We can do integrally constructed medians. We can do things that are going to last without having to fix and replace flex posts, all those different types of things. So there are a lot more flexibility with how we can consider this. I've seen projects where we just literally go in and cut out from the asphalt that's there and pour in a concrete raised median or something like that. And that can be done potentially as part of a retrofit, not having to go all the way to a full reconstruction in that case. And anytime you can keep the drainage where it is, obviously a good idea in that case. So, all right, another thing that a lot of the guidance won't talk about too much with class 4s is, and we'll take a break here in about another 15 minutes or so. But what do we do at driveways and conflict points? And there's starting to become more information about this, but it's still not really super easy to find in a lot of cases. And the things that we've learned are visibility is really important. We need to be able to have the opportunity for drivers to see bicyclists and vice versa for bicyclists to see drivers. We need to do everything that we can to make that conflict point or that interaction point obvious. And that may involve some level of combination between markings, signage, and other things that we can do to mitigate that point. So can we do things that slow traffic down when they're moving across that bikeway? So everything from our corner geometry to providing some type of traffic calming through a raised device, maybe we'll show some examples of that. Tightening the radius, maybe pulling the crossing back a little bit further to get a better sight angle. Those are all things that we can consider in terms of driveways. And this is kind of an interesting document. We pulled this together for the city and county of Denver probably about 10 years ago at this point. And we used the guidance in the AASHTO Green Book on basically turning vehicles and what type of turning speed that you're designing for from a driveway and for a minor side street. And using the 10-mile-an-hour and 15-mile-an-hour turning speed for both of these cases, we were able to kind of back our way into figuring out what that parking setback means. So if you're going to put a bike lane behind a row of parked cars, you need to pull that parking lane back far enough so that the bicyclist isn't just popping out unexpectedly from behind a van that's sitting there, for example. So how far do you need to do that? Well, if we use this formula from AASHTO and the table that's there, we can say, hey, if we need 50 feet of sight triangle, that basically means about 30 feet of parking setback from that driveway point. And that may not have to be done in both directions. Maybe it only has to be done on one side because that's the side that the conflict is coming from. If you have a two-way class 4, that might be something that you need to be thinking about a little bit more closely in terms of pulling the parking back on both sides and doing more from a marking and signage standpoint. Now for minor side streets, when you get up to 15 miles an hour, we're now talking about an 80-foot sight triangle. And so that creates this clear space. But we can use, if there's a crosswalk, if there's anything like that, that counts into that space. So we're looking at almost 50 feet of setback in those cases. And you might notice that some of these things are similar to the sort of parking setbacks that we already probably have in our zoning code and in our street requirements that are there, whether or not they're enforced, whether they have red curb, whether there are no parking signs there to enforce them, or bulb outs or curb extensions to enforce them. Those are questions that may or may not exist, but this is similar to that same concept of what we're trying to do with pedestrians. So if you do have a lot of parking and you're considering putting a class 4 in and you have a lot of driveways, you may find that there's not a whole lot of parking that remains afterwards. And then I begin to think, okay, well, if we're losing 40 to 80% of our parking by putting this facility in, is that the best facility? And then B, what if we just went to no parking? We're already going to have a pretty big Band-Aid ripoff at this point. What if we consolidated parking on one side, or what if we did something else and we're able to get a really nice facility in because of the amount of parking loss that's there? So that may or may not be possible depending on the project, but these are things that we're thinking about on all of our projects. And I still, all the time when I've reviewed plans from other agencies and other firms that are out there, I see this parking not being done correctly. So we don't have that setback. And so I'm often telling people that they're not going to get as much parking at the end of their project as they thought they were at the beginning. Another thing we can do is to make those conflict points as noisy and obvious as possible. We don't want a driver to be surprised by what's happening. We want them to give them some visual cues about what that actually could be. And so maybe it's an addition of a sign. And this is a sign that's been put in throughout the country. It's a variant of the R1015 sign, which is this turning vehicles yield to pedestrian sign. And this particular sign has been used a lot. It's in the FHWA planning and design guide for separated bike lanes, but it did not, for whatever reason, make it into the draft MUTCD that was out last January. And so I don't know why. There was a ton of comments on it. I don't know if it's going to get put in or not at this point, but it is a sign that a lot of folks do use. And I think it's fairly, I mean, there's better signs out there, but nothing that has, mostly MUTCD standard elements to it. So this is what you'll see. Another thing that we can do is raise the bikeway crossing up, and maybe your bikeway is already raised up and this is just a driveway approach type situation, or maybe what we're doing is actually physically just raising the bike lane for the driveway. And so here's an example from Seattle where they've just put this little kind of tabletop in on the bikeway, and that creates a vertical transition that motorists have to go over. So you have to go over this fairly slow. When you're going slow, you can stop really quickly. So if you hit the brakes, it's just a matter of a couple of feet, the car comes to a stop. If you're going faster, it's going to take longer for the vehicle to stop. You're going to be going faster, your reaction time is going to carry you further, and the chances of having a collision are going to be higher. So again, slowing that down is really important. And this is being done by our friends over in Fremont on a couple of their raised bikeways. So this is an example from Fremont in doing the same thing. The next thing that we can do is pull the bikeway back, try to bend it out, separate it a bit more, and increase the lateral separation between the bike lane and the driver. And this is a graphic that comes from a guide that NACTO put out about 4 years ago called Don't Give Up at the Intersection. And the principle here is that when you have a bike lane immediately adjacent to a vehicle, and we'll talk about this more when we get into intersections, you tend to have the bicyclist be in kind of the blind spot of the car. And that's why you'll see dashed out bike lanes and class 2s out there, because the idea is that you want the vehicle to get in the bike lane so that people are single file ahead of that conflict. And I'll come back to that in a little bit. But if we bend the bike lane out, as the motorist is turning around this corner, hopefully it's a corner that requires them to go a little bit more slowly, their sight triangle now is picking up more of what's going on around them and picks up what's those approaching bicyclists. So that setback, and we'll talk a lot about these setbacks when we get into protected intersections, but that lateral separation really does help in terms of creating conditions to be able to see bicyclists approaching. So I'm just going to move forward now into intersection treatments. And we're going to talk about the way that you conceptualize and think about what's actually happening. And this is kind of a unique perspective on thinking about intersections and what's really happening. How are the motorists and the bicyclists interacting in this conflict? Is it an intersection where the conflict, and all of these, you'll see a green arrow, that is the bicyclist path of travel, and the blue arrow is the motorist path. So which of these is going on? And I'm going to give you examples of how all of these work, but these each have their own advantages and disadvantages when it comes to the visibility, where the conflict is happening. Is it happening at the intersection? Is it happening in advance? Is there a better view angle at the intersection? So these are all things that are going on. And we're going to talk about each of these, and whether it's safe or whether it's comfortable or whether it can be both when you're going through your design processes. So let's start with a little question for everybody. And I get asked this all the time. And these are both combination lane approaches to an intersection, signalized intersection in this case. One of them has a solid bicycle lane. One of them has a dashed bicycle lane, which is what we typically would see constructed in California. I believe the one on the left is from Oregon, and Oregon state law says that you may not encroach in a bike lane for any reason at any time. And so they have solid bike lanes all the way up to all of their intersections, whereas in California, everything is dashed. So the answer is, question here is, which is safer? Raise your hand if you think the way California does it is safer with the dashed line, and leave your hand down if you think the way that Oregon does it is safer. One, two, three, four, 6, 7, 8, 9. Oh, I guess I've got a tally at the bottom. Okay, I'll give this another 10 seconds. Anyone in the chat box have any thoughts about why you think that's safer? Be curious to. And then I'll give you my answer, which will surprise you. All right, so it looks like I've got about a third saying they believe the California example is safer. So bikes should pass to the right of a turning vehicle. California increases awareness, potentially. Karen, I'm not sure. Not quite sure your comment left. Okay. Okay, so you're saying, yeah, we're going to get into through bike lanes here in a second. So cars and bikes should be single file to avoid the right hook, Jessica. Yep. So that's kind of what the California strategy is here. You know, you want the vehicle to enter the bike lane ahead of the intersection, get single file with bikes so that there is no conflict by the time you get to the intersection. Now, here's my answer to this question. The answer is nobody knows. And it's a really bizarre thing that in 2022, nobody knows the answer to this question. And FHWA, I believe, has a study that's started up that's going to look at this a little bit more in depth and try to figure it out. But there really isn't any research on whether or not each one of these is safer than the other. Oregon people believe the one on the left is, California people believe the one on the right is. And again, I don't know. I do know of a study, and I wish I could find this again. I haven't been able to find it in several years, but I saw a study about 10 years ago. It was a California study, and they did a camera onto one of these bike lane approaches, and they saw that only about half of the right turning motorists actually got into the bike lane. And so think about what that means from a bicycling perspective. You might assume that if the motorist doesn't get into the bike lane to make the right turn, that they're not going to turn, when in fact half of those vehicles in that right lane, in the rightmost lane next to you, still could turn when they get to the intersection. So that's not giving you maybe a whole lot of certainty. So we'll come back to this specific thing here in a second. But yeah, this is a really interesting question to me. It sort of blows me away that we don't know the answer to it at this stage, and I wish I could tell you something. So then the comment that I believe Karen made a few minutes ago, about getting the bicyclist to the left of the right turning motorist is what we typically try to do with, and this is a bit different, right? So we're going from motorists getting in line with or crossing across the bike lane here. We're now having the bicyclist or the motorist cross completely over the bike lane and then get into their own space and make the, and so again, we're moving that conflict point in advance of the intersection. There is a conflict point, there's this crossover. The way that we design this, it can be done well, it can be done not as well in certain cases, but typically this is the, I wouldn't call it the gold standard, but this is the design that most of us aspire to based on what the METCD and AASHTO say. Here's a couple of examples of this. And however, the problem comes from a lot of bicyclists feel safest next to the curb. They like having a curb there to provide them with some level of comfort that nobody's sneaking up on them from that side. And we've seen this both in visual, just video observation of different facilities. We've also seen it in surveys that people have talked about how comfortable they are. Now, any of the traffic engineers in the room right now might know that a lot of times we size our right turn lanes by the volumes that are out there. And so if you have a heavy right turn volume, you could end up with a very long, transition area, or you could end up with a very long part of where motorists might be passing a bicyclist on both sides of that bike lane. And so that's not really that comfortable from a standpoint on that either. So this, probably quite safe from a statistical perspective, but not very comfortable in that sense. So here's an example. I believe this is San Francisco. I don't know if this still exists, but this was a number of years ago when they were trying to make right turn lane conflicts a little bit more comfortable. And so they had they added the green and did some other things. And what we found is that green tends to make bicyclists a little bit more comfortable. Not all the way more comfortable, but I would say that this is probably fairly safe because motorists are typically, have good visibility of the bicyclist. If the bicyclist stays on the green, which green tends to keep people where they're supposed to be a little bit more so than not having the green. But again, you're not getting a ton of comfort out of this because you're going to have motorists on both sides of you. So is this going to get those enthused and confident or interested but concerned type riders? The answer is probably not many. So you could have a break in your level of comfort on your facility by doing this. And here's an example. This is one that I love to show from Tucson, Arizona. And this is basically connecting their downtown out to their suburbs on Broadway. And this is really one of the only ways you can get out because of the rail line that goes next to downtown. So this is showing kind of going underneath that rail line. And also there's a freeway here. And this through bike lane, so there's a right turn lane being created up at to get on the freeway. This thing's over 1,000 feet long. They put the green down on it, but still it's not comfortable. And so then, engineers have thought, okay, well, if we don't want to have bicyclists out in the street like this, kind of hanging them out to dry like this, what if we just switched them over later on? And so then we have some of these that have popped up. And I believe this was taken not too long ago somewhere in San Mateo County. But is this a good idea? And I'm curious from in the chat box right now if anyone has any thoughts on why this is a good idea or why it might not be a good idea. We'll come back to talking about that. Unclear, yeah, Hugh's saying unclear who has priority, and hopefully Hugh has good reason to know that. But so you see from the top here, these two angles that we've got, and we're crossing motorist over bicyclist at a similar acute angle. And you have to wonder at that point, who really does have priority? Now, the green that we've got shown here tells me, tells the bicyclist maybe that they have priority. This is a little bit unclear from a vehicle code perspective because the bicyclist is going on the through path, but the car is also, potentially going through or potentially turning. So it would probably be legally the right of way for the bicyclist, but from a vehicle perspective, that's not exactly clear either. So this is one of the only things that the NACTO bike guide says don't do specifically. because of this. I know in San Diego about 12, 13 years ago, they did one of these and they saw a bunch of crashes happen right after it. And they quickly went out and removed it. So this would be something maybe to think about, but I would say this is not a good idea. Now, bicyclists like this because they feel like, oh, I've got this green carpet out in front of me. And what I've noticed when I'm looking at these is most bicyclists will not look over their shoulder. They see this priority that's been given to them, this green dash, and they're going to just follow this very 5-foot wide path that we've created for them to go through here. So I would say this is probably not safe. I might even put this into the red color here. But it is, most bicyclists will say, hey, this is pretty comfortable because of all the green that's been provided. So I would say definitely no, this isn't a good idea. And here's again from the NACTO guide saying don't do this. But what's happening is here we need to get bicyclists to cross over. And is it a good idea to cross them over very specifically within a 5-foot area, or do we want them to pick when it's the best time for them to cross over? And so this middle graphic, which we're showing here, is probably a better way to go about doing that. Let me go through one or two more slides, and then we will we'll take a quick break here. So alternatives to having the crossover, one would be you just keep the bicyclist at the curb, and then you use a bicycle signal, which we'll again talk about later, to separate out the turning movements from the bicycle movements. Very comfortable, very safe. So very comfortable, very safe, but maybe not great for capacity. And I'll talk about some of the other disadvantages with this situation also. The other alternative would be to drop the bike lane completely and reestablish it on the other side of the bicycle of the right turn lane. This is definitely not comfortable because bicyclists are now, they have an undefined area which they don't like. But what I've noticed in looking at these in my experience is that virtually 100% of the bicyclists will look over their shoulder and judge the correct time to cross over. So I rate this as pretty safe, but really not comfortable at all. So this could break your usage along a corridor, and I typically would not advise anyone to actually design this into a new project. And we're frequently trying to eliminate this from existing roadways when we're doing retrofit work so that this doesn't happen anymore because of how uncomfortable it is. Doesn't mean that it's not safe or overly dangerous, I would say, but it is a huge weak link in the system. So with that, let's take a 10-minute break maybe as we're getting further into the training. And so let's come back at 10:35. Does that sound good? And then we'll be back here at 10:35. And we'll be back in 2 minutes, 2 minutes. All right, we're going to pick it up again. Anyone have any comments or questions about anything that we've already covered? If not, I can keep moving. Okay. Happy to take any questions at any point as well. All right, so we talked about the drop lane. You know, safety, probably okay, comfort low. Let's return to the dashed out bike lane here in California. And so this is, again, the motorist getting into the bike lane before positioning to make their turn. We've also talked about how this might not be reliable, right? Like not every motorist may actually do this maneuver correctly in order to provide that level of certainty with bicyclists. So in that way, I'm going to say, you know, I'm going to lower the safety to an orange. Like maybe it's safe, maybe it's not, because not everyone's doing it correctly. And then the comfort here again is quite low because you're taking that dedicated space for bicyclists, and you're basically removing that level of separation through intersections. So again, this isn't going to move the needle particularly far when we're trying to make our bikeway networks more comfortable and accepting to different types of ability levels and ages. So what could we do? Well, if we had more space there, you know, and again, this is just an option that we're going through because it exists, is to actually make that right turn area and eliminate that bike lane a little bit further back and actually create a full, even if it's short, right turn only lane. And by doing this, we're improving upon the image that we just saw here, because in this case, not all cars are going to use that space. In this case, I would say virtually every car would that was going to be turning right. And so we are providing that certainty to a bicyclist as they're approaching the intersection. And we're also keeping nice alignment on the far side. Bicyclists can clear the intersection and be, you know, directly in the bike lane again on the far side. So again, we want to keep this as kind of short and compact as possible. You're not going to have huge right turn volumes in this case, but it is an option out there. And to me, this is, you know, a little bit safer than what we just saw, because it's going to have, you know, more certainty in terms of all of the vehicles are going to be using that space correctly. But again, the comfort is lacking because you're bringing cars into the bike lane and you're sort of terminating it. And this can be done with a traditional buffer, like we're talking about here. So the bike lane plus the width of the buffer can equal the width of a right turn lane. It could also be done by combining a parking lane and a bike lane and creating the space. So if you have on-street parking and a conventional bike lane, you can create the space at an intersection in a lot of cases. But marking it out as a turn lane, I believe, is a good way to create that certainty. But is this the best type of a treatment that we can do? Again, kind of partially safe, but extremely not comfortable. There's a lot of things under the mixing zone umbrella. I'm going to show you one example from San Francisco, but a lot of cities have experimented with this, and they've really looked at it for the last decade. And I'm not seeing too many new versions of this get put in. I think we've got some new things to show you here, but this is from San Francisco, and this is called a mixing zone. And what it's doing is it's bringing the motorists in. It's giving them a yield point to say, hey, this is where you have to yield to bicyclists. You're having a little bit more of an indescript switchover perspective, and then this could be a shared lane, shared turn lane, bike lane. It could also be somewhere where the bicyclists are shifting over like this. So here, this is better by far than just having the dashed line sort of striped the mixing zone, or the dashed markings for bicyclists connecting the two like we saw earlier. So this is still, you know, a bit more of an angle, but we're providing clear priority, and we're giving them some additional information on what's going on here. And so this has a slightly different meaning to it. So I would say that the comfort level is up here, probably has about the same level of comfort, you know, in terms of safety, maybe a little bit improved from what we talked about before. And so this is a way to change things a little bit for the better. But again, you know, is this the best that we can do if we have this amount of space to go forward with? So what we're seeing now also is the bend out protected corner. And we'll talk a lot more about protected intersections, but we'll get into some of the elements that make them important right now. And this is a graphic from the 2015 FHWA separated bike lane planning and design guide. So this is a kind of what we might be able to use for class 4s, but this could also have relevance to any class 2 that exists, that you're just trying to do something better at the intersection. And again, if you remember that graphic that we showed a little while ago with the car turning with a greater setback, you're giving more of an opportunity for the driver to bring the bicyclist into their kind of view triangle here. And so the critical length for this, various guides have different dimensions. I believe the next AASHTO guide will probably say 6.5 feet is the minimum setback that qualifies as a setback crossing. That gives you some level of benefit. There's a little bit of disagreement right now in the industry about whether that's enough. In some cases, if you're right next to the driver, you're visible in their mirrors. But if you're set back, you know, a full car length at the intersection, you're also visible. But if you're in that medium area, there's some disagreement about whether or not there's enough visibility and overlap, particularly with trucks and buses that might be turning, where you might not be in their mirror area where they would be visibly able to pick you up by using their mirrors only. So, and those vehicles tend to be a little bit more difficult for the driver to see out of. They're more restricted from a visibility perspective. So if you're not in the mirrors, you may be invisible to them. So there's a bit of debate on that right now. But what we recommend is to try to get this to as close to a full car length as we can. So 15 to 20 feet typically, and that gives you enough space to have this area work. And again, if you can maintain a slow corner at that area, that does tend to improve your safety over the rest. So here is an example from Santa Monica, and this is a protected corner on their bikeway network. And you've got this corner safety island, which we'll talk about here. And then you can see this interaction is about to happen here, but this motorist can see the approaching bicyclist. So we've seen pretty good results on these that have been installed. We're seeing them as comfortable because you're maintaining that protection all the way up into the intersection versus bringing cars into the bike lane ahead of time. And we're seeing that this interaction is pretty safe. And some local information that I can give you comes from SFMTA. They did their first intersection like this, I think back in 2016, 2017, kind of in that area. And they did a study in looking at it. And so here's that setback right here around the corner. They have a little bit of a truck apron here too, so they can handle wider vehicles, but keeping most of the passenger vehicles working in this tighter corner here. And what they found is, in this case, that they had 96% of drivers approaching the bicyclist yielded to that bicyclist. And from a pedestrian standpoint, 100% of the observed drivers yielded to pedestrians. So, you know, like, wow, it's like, to me, that is kind of compliance and behavior that would be unheard of through any type. I mean, even signals, you're not going to get 100% compliance with in all cases. So that to me is very telling in terms of how this works. And they also found that most vehicles turned below the targeted speed that they were looking at. And so that was also contributing potentially to safety. So I don't know how this intersection has been doing in the years since, but from initial study, it looked pretty darn good from that perspective. So I'm going to go ahead and rate that both safe and also comfortable in terms of going through that. So this covers most of the right turn kind of interactions that we can do. We're definitely seeing a movement towards trying to protect that corner a bit more using the protected corner geometry. There's a little bit of interpretation of vehicle code in terms of how that aligns, because what the vehicle code will say is that the motorist has to turn right from the rightmost lane. And if a bicycle lane is there, then that would be the rightmost lane on the roadway. But if it's separated and pushed back, that would not be considered part of the roadway, and that then fits and makes sense. There's an alternative type of intersection approach that I don't have any pictures of here, but NACTO is pushing it, and where you don't have enough space to fully set back the bike lane, they're claiming it's still worth it. And again, we don't have data on this yet because of that problem that we talked about earlier, but they call it a dedicated intersection. You would bring the protection up to the intersection, keep the vehicles out of the bike lane, but you wouldn't have that setback. You would have an adjacent crossing at that point. I don't know, again, is that safer? I know that it's more comfortable. And I think in certain cases, in the Portland context or in the Oregon context, they've shown that overall, they have had some areas that they have seen, a high incidence of right hook collisions. They've done some interventions at those locations to address those. I'll show you some of those conditions when we go forward. But overall, it hasn't seemed to play out as a huge, it doesn't seem to be a huge safety issue that's stepping out at it. So adding more protection there could be a good idea. A lot of the class 4s around the country are doing this. It is a little bit of a gray area again, but I'm seeing good results from if we can do all these things to get the turning speed low, to get maybe some type of vertical deflection in, to maximize your visibility in your sight triangles. All of those different things are going to create the conditions where that's going to be a safer interaction than doing none of them. So those are all things that we do know. So that covers right turning motorists. Let's talk now about left turning motorists at an intersection. So right hooks are something that most bicyclists are very aware of and are very worried about. However, the left turn is also extremely dangerous for bicyclists. In fact, I think in most communities, there's more left turn crashes than there are right turn. And there's really not as many things that we can do about it from a geometry perspective or from a bicycle lane approach design perspective to deal with the left turn, if we can't get rid of the left turn at all. So we learned last time in the PED module that if we can get rid of our permissive left turns at an intersection, we can reduce the number of crashes at an intersection by up to 70%, according to all the studies that are out there. So intersections that don't have permissive lefts have 70% fewer crashes than the ones that do. That's a pretty big takeaway. And that would include pedestrian crashes, bicycle crashes, and motor vehicle crashes. So those are all things that we can be looking at. Now, if we can't get rid of permissive lefts, if we can go protected permissive, that's better than just plain protected or permissive only. But there are a couple of things that we can do from a bicycle standpoint that kind of parallel some of the things that we can do from a pedestrian standpoint. And those are to put up additional signs, try to have devices like flashing yellow arrow that are going to add a little bit more awareness. I think flashing yellow arrow reduces crashes by 15 to 25% in some of the studies that have been done on that. So that can be good. To try to have the protected then the permissive, so that you're hopefully clearing any accumulated bicyclist, queued up bicyclist out of the intersection before a motorist has a chance to actually come in contact with them in a left turn. Or I forgot where I was going with that, but from a signal perspective, we can do that. There could be a bicycle signal component of it where you separate out the right turns, and we'll talk about bike signals a little bit later, but where you separate out the right turns and you allow bicyclists to go through on a green bike signal, and then you shorten their crossing interval, and then you allow the vehicles to go that are able to turn. And so that would be safe. but there are some issues with that, which I'll talk about when we get into the bicycle signal module, which we'll get into in more detail. All right, so another thing that we can do is to focus and tighten the left turning path. And we can do this with what we call a hardened center line. And that can be a number of different things. It could just be extending a raised median out into the intersection far enough to actually encompass the bicycle and the pedestrian crossing, or it could just be a little rubber speed bump on the roadway. And what we're trying to do here is tighten the left turning path of travel, slow them down, and to reduce the conflict area that type of a crash could occur. And so you can see here on the left, a motorist can take this at pretty high speed, and they're able, you have all this extra space versus over here on the left or on the right, where that crash can actually happen. So we have lower speed here, we have a more focused conflict zone than we have on the left, and those are the ideas that go behind this. And so again, that can be just a median nose if you already have a raised median, or it could be a set of speed bumps that goes in there. And in most private passenger cars, you're not going to have any real chance of a damage or anything with this, but they are going to tend to try to avoid it, go around it. So that can be helpful. And this is an example from Oakland, and they did see some good results from installing these. All right, so that's motorists turning left through the path of a through-moving bicyclist. So now let's talk about intersections when we're trying to facilitate a left-turning bicyclist. And this is also something that we don't have a ton of guidance for in most of the older parts of the manuals that are out there. And this can be another source of reducing people's propensity to bike, because left turns can be very uncomfortable. You have to cross, in some cases, multiple lanes of higher speed traffic that's coming at you. You not only have to do that, but to position for that, you basically have to, if you're going to do this like a vehicular cyclist, you need to merge into that left turn lane, which means you're experiencing more discomfort upstream of the crash, or upstream of the turn, in addition to potentially having to permissively turn across traffic when you get there. So this is a maneuver that only a very small percentage of bicyclists, people that identify themselves as an experienced bicyclist, in fact, would probably be comfortable in making. So in this case, again, low comfort, but probably fairly okay safety overall. So other things that we can do from a very minimal standpoint, maybe we make a left turn pocket just for bicyclists, and at least that helps on the near side of the intersection, but it's still really not going to fundamentally change what's going on with that. And there are a number of communities that have experimented with these. I haven't seen too many put in recent years. We use them sometimes now where we're providing for a bicycle only left turn, like the bicyclist is the only one that can left turn across it. And we do that for crossovers or in areas where we're doing sort of bicycle boulevard crossings. And I may show some examples of that when we get into our class 3 bicycle boulevard module here in a little bit. Now, another thing we can do, in fact, what you'll notice if you sort of go out and stand behind a corner for a while with some bike lanes is you may see some folks come through that actually will stay in the bike lane, come across the intersection, jump up on the corner and wait, and then cross as a pedestrian and then rejoin the bike lane. And that is a very natural maneuver to do because it makes sense. You're not actually exposing yourself to the same level of potential conflict that you would be in making this vehicular maneuver. And there's a device out there that we call the two-stage turn cue box, which basically legitimizes that type of a maneuver. And this provides a spot where you can continue through the intersection on the prevailing green. You post up at the box and you wait for the intersecting signal to turn green, and then you continue through straight. And this means that you no longer have a lot of those different types of conflicts. It's a lot more comfortable. However, there is some compliance issues with this because some people don't really know what it's there for. So you're going to see, some existing more confident bicyclists continue to make the vehicular maneuver, but having this here is a good thing for people that are less comfortable in terms of making those lefts. Now, if you're relying on this for every intersection for people to make lefts, it can get a little bit busy. It can get a little bit maintenance intensive. However, if there's some good places out there where you've got a pretty consistent bicycle flow that's going to be turning, for example, to get to onto a certain other key route, this can be a really good device to install in those types of intersections. So there's a lot of guidance on this in the interim approval that's out there from IPHWA. NACDO has a lot of really great examples of how to use this type of a device. And the key here is that you want it out of the way of through moving traffic. And so where this gentleman here is waiting, that can't be an area that is in conflict with any other moving traffic. And so it has to be sort of a sheltered area. And you can do that in a parking lane. So you can see there's a parking lane upstream here, and that is creating the shadow against the moving lane of traffic, which is happening out here for this individual to wait in. So that could be done as well. All right, the next thing I wanted to talk about was the bike box. And I have a lot of conflicting emotions and feelings about a bike box. It happens to be the only tool in our toolkit that only works some of the time. And let me explain what that means, particularly if you're trying to facilitate left turns. And I'll come back to other reasons for it. But here, so we've got a red light on the main street. Bicyclists, that red light changed too quickly. So they're supposed to get into the bike box, position, turns green, and then you can make your left turn in parallel with the left turns that are already here, or you can come all the way and get into the left turn lane and clear. So it works if you arrive on a red light, but if you arrive on a green light, it doesn't work. So then, how do you get into that? How do you get into that box? How do you make your left turn if it's green? And so I tend to not use bicycle boxes very often. The context that I use them in is very, very narrow, and I like to use them on side street approaches that are actuated. So here's an example from Mountain View. This is one of our projects, and this was a crossing for a bicycle boulevard there. And here we basically create a bicycle lane, a short bicycle lane that accesses the bike box. There's detection for bicyclists, so they can turn left onto the main street that has bike lanes, or they can continue straight and stay on the bike boulevard. There's some crossing markings here to show them where to go. And virtually every time you show up here, you're going to be arriving on a red signal. The bike box is going to work, and it works out really well. Where it has worked well on major streets is not necessarily for accommodating bicycles left turns, but to actually be there to raise awareness of a right turn conflict with motor vehicles. And so in that case, the bicycle box can reduce the number of right turn crashes that you would have with motor vehicles. And Portland's basically shown that with a number of different locations that they experimented on and took a bunch of before and after data. They had 2 locations where crashes did go up after the bike box. They went back and looked at those, and they realized that both of those were downhill approaches. So bicyclists were actually sort of passing motorists and picking up speed as they were heading into the intersection, and motorists weren't able to detect that they were arriving. The city went through and changed some things about those approaches. In one case, they actually put a detector upstream. And so when a bicyclist was approaching the intersection, it'd be a little blank out sign that would say, hey, bicyclists are approaching, be careful when you turn. And that essentially reduced the crashes back down again after that. So downhill approaches are not good, but bike boxes can be good for treating right collisions, but there are other things that we can do too. I think the setback crossing has a much better potential to address right hook collisions. Another thing they're really good for is if you have a lot of bikes. So if you've ever commuted in an area that does have a lot of bicycle commuters, and I've had this experience commuting in Portland during a PM peak, and we have this 6-foot wide bike lane approaching the intersection, but there's 40 bikes waiting, and so people are kind of trying to squeeze into this thing, spilling out, and really it took some time for all that chaos to kind of clear, and all the vehicles there sort of were just afraid to move, and so they had to wait for all those bicyclists to clear out and get in the bike lane and keep going before they could turn right, go straight, whatever. And a bike box has the ability to store more bicyclists at the front of the intersection, and so you actually can clear an intersection more quickly using a bicycle box than you can without. And so that is another good use for using them. So again, these are my own guidance. You'll see this a little bit between the lines in some of the guidance that's out there, but the MATCD, or at least the interim approval, is very silent in terms of when to use a bike box. It just gives you the conditions by how to design one. So here, again, queuing large numbers of bikes to quickly get them out of the way, so you can have, it's a capacity benefit. Another one would be if you're arriving on red almost all the time, then they can be good for left turns or for whatever, just getting people to the front of the queue again, or where you have a history of right hook collisions. Generally don't use them on higher speed multi-lane approaches. They're not going to do much. They're just going to create indecisiveness. They're going to create, what do I do here situations, because you're probably going to have a fairly substantial amount of green time. So bicyclists will be arriving on green and won't know how to use the bike box in those cases. And I have had people pull me aside at public meetings asking about what they're supposed to do. And I said, just don't use it. And so you'll see here on the screen, actually, and me go back a couple, we have a shared lane marking in. If you wanted to go right here, we wouldn't ask you to get over into this bike lane. You would just stay in this lane and go right across the intersection. So those are things to think about also. And then I avoid the mainline intersections. I also avoid using it as a left turn treatment unless very specific conditions are present. So I had one that I designed where we used it for lefts. It was a intersection where about 90% of the traffic was turning left at that case. And we had a right turn only lane inside or outside of the bike box. And so we weren't interfering with right turns. We were just using it to position at the signal to make a left. And that did tend to work pretty well. We didn't have any issues with that. So those are also things to be thinking about. So here's another example from San Carlos. And what I love about this one, it is a multi-lane bike box, which let me come back to that in a second, but it does have this bicycle detection built in. So if you pull up at the regular approach, you'll be detected, and also if you move into this area, you'll also probably be detected by these parallelogram loops that have been put in. Type whatevers, I forget what these are called. But one thing, if you have a multi-lane approach like this one, some things that you have to worry about it, particularly if you're using it for left turns, which I've already mentioned, maybe to have a second think about whether there's another way to do that, is that if a bicyclist is positioning to get over here and they're sideways and the light changes, that's also kind of uncomfortable. And so bicyclists actually, there is a requirement in the interim approval where you have to have a pedestrian countdown timer at the intersection so that you can see when you make that 90-degree turn and you're now broadside to traffic that could be released, you at least know how many seconds you have left to finish your maneuver in doing that, which virtually every signal should have those adapted to it by this point. But it is something to think about. Another reason why I don't prefer to use a bike box to turn people in left directions. Okay. Any questions on all of that? That was a lot of information and hopefully some context that was helpful in thinking about some of these different maneuvers to make. I find that a lot of times when we're designing a corridor, we're thinking about what's going on along the corridor, and we very seldomly pay enough attention to how bicyclists get on that corner and how on the corridor and how they get off of it. Because every potential cross street is a place where a bicyclist could turn left and leave the corridor to reach their neighborhood, reach a business, reach a school, whatever it might be over on that side. And a lot of times we kind of create these really good, high quality linear corridors where if you're trying to get from, do miles in them and get from end to end, they're really great, but they don't always provide that level of permeability to the side, the adjoining neighborhoods, I should say. Okay, don't see any chats coming in. So let's keep moving. And we're going to move into a slightly more detailed module on protected intersections. So I've talked about all these different things that are vehicle conflicts at the intersection, paint, posts, green, different positions, and we've talked about the setback crossing. So let's talk a little bit more about the setback crossing and what we can do to actually create sort of more holistic intersections that have that from all angles. And so here's an aerial view of an intersection in Fremont, California, and they built a couple of these along one of their intersection upgrades. Fremont's been one of the most aggressive communities in the US in terms of doing protected intersections. I forget how many they've done now. I think it's more than 10 maybe at this case point. And I know that they've got a bunch more in the pipeline for future projects and grant applications they're looking to do. They've had pretty good feedback. This I would call their Gen 2 example. We've got a prototype for kind of a third generation one that treats things a little bit differently, but a lot has been learned, and those folks over there are more than happy to talk to you about their experience in terms of doing it. But let's take a, well, Yeah, so Jessica has a comment. It helps that their streets are ginormous, but they didn't reduce their travel lanes in most cases here. What they did was you can see the old channelized right turn, the old curb line on the side here. I always forget that you can't see my mouse on the other monitor. So here's the old right. So they're requiring a slower right turn at the corner in doing that. So I'll show you some examples of other types of intersections here too that are smaller in some cases. But the key anatomy that we're looking at with a protected intersection is we're bringing that level of protection of the bikeway and the separation all the way to the intersection. And when we use this additional piece of separation called the corner safety island or the corner refuge island in the middle of the intersection there. And what that's doing is it's giving a place to wait for bicyclists that is now well forward of the vehicle stop bar, which they would have been at in the previous iteration of the design, which means that they have a physical head start out into the intersection. So there's a really good chance that if bicyclists are queued up there, they would clear the intersection before it's even possible to have a right or a left turn actually conflict with them in that location. So we're getting this physical head start. We could combine it with some type of temporal head start as well, using some type of leading interval, but that's a topic for another conversation. We have the setback bicycle crossing, which we've already talked about. And again, if you arrive after that first group's kind of cleared out, you have this setback to help protect you going through the intersection. Now, for bicyclists moving through the intersection, obviously through movements are really, really easy. You've got just a really simple way to get across. If you're going to turn right, you don't have to even interact with the intersection at all. You just make a right turn here and you're on your way into the next bike lane. If you want to make a left turn, basically this is approximating that two-stage turn cue box. So we're bringing you through the intersection, we're giving you a place to wait, and then we have you can continue through on the next parallel green. So a lot of benefits in using this. The benefits translate also to pedestrians in a lot of cases. There's more pedestrian space, there's shorter pedestrian crossings. Depending on where you locate your push buttons and what type of accessibility features you install with the protected intersection, you could actually, improve the efficiency of the intersection. And we learned last time when we talked about larger intersections, a lot of those are really controlled by how long it takes a pedestrian to get from one end to the other, because you have to have this very long clearance time to be able to get pedestrians across. So you may, fully accommodate all of your motor vehicle traffic, and yet you're still devoting green time to that approach because a pedestrian is still making his or her way across the intersection. So having a more compact intersection will give you greater flexibility in your traffic signal operations, more flexibility in terms of coordination, and to dynamically serve the demand that is approaching from different legs. So there's a lot of benefits that you can get from that. And let me go back to the Fremont example here real quick, but you can see what they did in their example here. Their first generation had the accessibility tiles on both sides. Let me see if I can draw here. Tape. So they had, detectable warnings here and here. And what they found was that the local disabled community, and this is the way that it's shown to do in most of the guidance that's out there. And what the disabled community said is, okay, they cross the first one, they think they're getting out into the street, and then they get to the second one, and then they try to figure out what's going on. Okay, what did I just cross? Is that a bike lane? Is it a traffic lane? And then, oh, there's another detectable warning. And by the time some of them have sorted all of that out, they've wasted some of their time and they can't get across the intersection the rest of the way. And so they're confused by what's going on there. And so Fremont, in their second generation, what they did was they removed the detectable warnings and they tried to delineate through the edges of their sidewalks. So this is very clearly leading you to one of these crossing points. For people that have some vision, they've got this really high contrast in terms of the bikeway area and the non-bikeway area. And they're having the pedestrians cross from the refuge area. So there's a push button here. You get to there, it makes a lot more sense for people with different types of impairments, and that tends to work really well. What we're doing for their third generation is we're actually sort of terminating the bike lane almost before you get to the corner, and we're making sort of one wide, larger ramp. And Davis has an example of something similar to this from one of their projects in 2015. And this ensures that bicyclists are told, hey, you have to yield to pedestrians, but you can still use the corner to make your movements. And then after you complete your crossing, you get back into your bike lane and on your way. And you're told to yield to pedestrians. So, I don't know. I see a lot of different design philosophies out there. We do a bunch of projects designed right now up in Canada. We're doing a lot of stuff in the province of Ontario. And in Ottawa, for example, they want to have delineation here and bring pedestrians out and take advantage of this shorter crossing, but everything's very regimented and delineated. In Toronto, they don't want the problem at all, and so they actually won't let you use the pedestrian refuge as a benefit, and so they put the push button back here, and this is all open, and you have to cross as a pedestrian from behind the protected intersection, even though bicyclists get the benefit of using it in that case. And so it's a really interesting dichotomy in terms of how both of those cities in the same province are actually approaching those types of problems. So I don't know where this is going to go. There is some research underway right now with FHWA to try to address some of the accessibility issues, because ProAg doesn't deal with this level bikeway with a sidewalk. Now, if you can get some type of elevation difference between the two, at least where they're adjacent to each other, that can provide that level of delineation, some short curving, keeping pedestrians basically in their pedestrian space and keeping bicyclists in their bicycle space. Those are different ways you can do that. It can get a little tricky from drainage perspective, other types of facilities there. So there's a question from Jessica. Is the bike facility at the intersection asphalt or concrete? It's concrete, but it has a green surface treatment put over it here. And I do recommend using concrete where you have these very protected areas, because if you do it in asphalt doesn't last as long as concrete, and it's a real nightmare to go back in there and resurface that little strip of asphalt at some point in the future. And I've got some pictures of things that were done like this 10 years ago, and they're starting to look pretty rough, and the concrete next to it still looks fine. So I typically recommend using concrete. There are additives that you can put into concrete to color it. And so there's been other cities that have used a integrally colored additive to delineate the bike area from the pedestrian area, but still keeping it concrete and low maintenance. And so like Austin, for example, uses a very kind of brick red color for their bicycle lane approaches. They still use the green in the intersection. You don't have to use green. It's really an architectural treatment when you're in the corner, but once you get to the intersection, you do need to use the green. And so there's red, there's Minneapolis and other communities have used a black additive that they call black ice. It's a pigment that colors the concrete a dark color, and it looks kind of like asphalt, but it's not. It's still concrete. So those are nice treatments that you can add to it. All right, so that's our accessibility discussion. And let me show you some examples. So there's a few ways to do this. You can do it as a full intersection reconstruct, where you're going out there, you're moving signal poles, you're moving curb lines, you're moving catch basins, you're moving utilities. All this is happening. And here's 3 examples in the state that have done this. So San Luis Obispo actually has, I think, 2 of these on the ground now. There's 2 more in design, and they're considering it as their standard going forward. So some really neat stuff that's happening on the Central Coast. Davis was the original implementer of the protected intersection. This is an example that has sort of class 1s on the side, but it also has buffered class 2s. And so you can leave the class 2, get into the class 1, get up to the intersection, cross, and then you can rejoin the class 2 if you want. And then here's another view from that Fremont example here. So these are all kind of full reconstruct projects, a little bit more expensive. Good to do if you already kind of need to replace your signals, but if you don't need to replace your signals, you could consider what we call a surface concrete retrofit. And in this case, you're typically maintaining your curb lines that already existed at the intersection. The signals will stay in the same place. Your push buttons will most likely stay in the same place, and your drainage will stay in the same place, but you're going to float these islands out into the intersection to create the features of the protected intersection. So these are all 3 examples, one from Berkeley, Salt Lake City, and then Fremont. Again, that's one of their earlier ones. And then you can also do it as a quick build. And I think I showed both of these examples already before, and these both essentially use the pigmented color. Flex posts, these are both using those K71 bollards that are a lot tougher and withstand impacts better. And you probably won't have to replace these quite as often, but they are a little bit more pricey to put in. But yeah, we can build these pretty quickly. We don't have to make a ton of changes. And when you're using these with one-way class 4s, they work really, really well. They also work really well with two ways, but then you have to worry about permissive lefts and conflicts because you're having a bicycle direction come from the opposite side that's expected from motorists. There's a little bit more to think about, but those also can be made pretty safe. One huge benefit that I see in using protected intersections is dealing with transitions. And so this is a project that we worked on a while back that's in development. And we had one roadway that had a two-way class 4, and then we had class 2s and class 2s and class 4s one-ways on the other streets. And the protected intersection offers a way to basically mix bicyclists behind these corner areas and sort out all of those transitions without having any awkward, diagonal crossings or weird things that are going on through the intersection. So it can be done that way. And I wish I knew what the status of this project was, but several years ago, I was reviewing a project in Redwood City that was similar to this. It had a class 1. It was at a 101 freeway interchange, and they were looking at using protected intersections to help both make the intersections and interchange points safer, but also to handle some of the transitions between the class 2s that were there and the class 1s that were on the side of the road coming into that area from different angles. So it was kind of an interesting design prospect. We did get to a kind of an interesting design, but I don't know. I checked Google Street View and Earth the other day to see if it had been built, and I didn't see any evidence of it, but it is hopefully still moving. Any thoughts or questions on protected intersections before I move on to bicycle signals? All right, well, if you do have any questions, feel free to throw them in the chat pod and I will address them when we get there. All right, so bike signals. Quick question. You can throw your answer in the chat pod. There's a little trivia question. Where was the first bike signal in the United States? Feel free to guess. Got 2 votes for Davis. More Davis. All right, saying Portland. Anyone else? Tucson. Tucson has some old ones, but I think Davis, in fact, is the oldest one. This is a picture of the first bike signal in the US. And I think it was done either late 90s or early 2000s. And it kind of set the standard for a lot of the way that we've worked at them going forward. I think, honestly, I kind of wish bike signals had evolved to be more of a pedestrian signal head cabinet type thing rather than a 3-lens traffic signal type thing. I just think there'd be less confusion with them, but they have evolved and we have standards. We now have interim approval 16, which gets into how you can use bike signals from a federal level. California has its own guidance, which came out before interim approval 16, which is in the California METCD. And there's a lot of good information out there, a lot more standard in California. What I'm showing you here from Long Beach, I don't know if they've changed it, but you would now have a sign on the, there was a lot of experimentation to try to make them stand out differently than traditional traffic signals. But I'm going to go through all of the different uses that we have for bike signals. Now, the first use is to separate bicyclists from turning vehicles. And we use this as just checking time here. We use this basically, in some cases, like we mentioned, we might want to keep the bike lane to the right of the right turn only lane because there's a high amount of traffic and we want to keep it separate and comfortable. So we use a bike signal for that. There might be left turn conflicts that we're trying to separate out from interacting with bicyclists. We can have some interesting possibilities that open up, which I'll talk about later in terms of signal timing. But these can be a huge safety and comfort improvement from before. So we're going to have safety and comfort out of this. There is some question about where and when, what type of traffic thresholds might make this a good idea. Typically, when you have more turning traffic, the more utility that you're going to get out of separating that out, both in terms of not delaying the turning traffic by having to wait for bicyclists and pedestrians, but also in making that conflict a little bit safer. The Massachusetts DOT is the only one that has released any guidance in terms of what that number might look like. And what it says is that if you have more than 150 right turns an hour in the peak conflicting with the bike lane, it might be a good time to consider the bike signal. And then if you have a two-way facility, if you have more than 50 turns at all passing through the bike lane, it's probably a good idea for a bike signal. Myself personally, I try to use bicycle signals anytime I'm using a two-way bike class 4 at an intersection. That just from my own standpoint, liability, it just seems like a much safer bet to go ahead and do that. If you have dual left turns or dual right turns, particularly with dual right turns like at freeway ramps and other types of larger intersections, the bike signal can make it way safer to do that, because you no longer have to have the bicyclist transition over 2 lanes of traffic. One's really bad enough, but 2 is really uncomfortable, and most people won't do that. So if you have multiple turn lanes, that's a good solution to do that. And then like we already talked about, where you have sort of a through lane that drops into a right turn only lane, you don't want to cross bikes over that right turn only lane because of the degradation in comfort. We can use a bicycle signal at those locations, which might not meet that 150 right turn an hour restriction. We could also think about other types of treatments that we talked about, but the bike signal is one of those treatments. So that's one use here. We can separate bikes from turning vehicles. Another use would be to provide bicyclist direction in a contraflow type movement. And so here's an example from Denver, where this is a one-way street coming at you. And because there's all these different, there's like 2 grids meeting each other at this location. That's the city building there in the back. And this bike lane would have had to do a really circuitous, weird movement to go around this. And so they just allowed bicyclists to come through. And so the bike signal controls that contraflow direction. So we need to have some level of guidance at a signalized intersection for bikes. And so that can be a place to use them. So there are a lot of examples of contraflow facilities for bikes using bike signals. Another one would be, so number 3 here, using a bike signal to get across a major arterial in a condition where there is no traffic control ahead of time. So this is a neighborhood bikeway or a bicycle boulevard in Fort Collins, Colorado. And we installed 3 of these with one project. A couple others have gone in. I think we've got like 10 similar devices around the city at this point. But this is a previously uncontrolled intersection. We didn't want to attract motorists into it. So I've got some other examples of this in California in the future. But we're forcing vehicles to turn right here and not to go through, and we're giving bicyclists a way to do that. And the bike signal provides that level of direction for that. So it could be done for kind of funky, weird crossings. And other examples of funky, weird crossings are for different types of unique geometry. So there's a lot of weird one-offs. And I found that in my career, a lot of those weird one-offs tend to find me. And it makes really interesting type of engineering work. And so here's an example from, this is in Missoula, Montana, and they have a rail trail that is basically piercing through a grid at a diagonal. And so we had a couple of intersections which were really weird and big. And if you were to basically continue along the rail line, you would need to go substantially out of your way and cross multiple other legs to get across. And so we had this thing set up where you couldn't push a button to call this signal. It was an embedded loop only under the ground where it says wait here. And then it would call a signal. And so you can see what that looks like here from the aerial. And I believe we phased it so that if the bike crossing was going, left turns could go from, so if this bicycle crossing was going here, left turns could go this way, and left turns could also go this way during that phase. So we're able to pick up a little bit of capacity out of doing that, but kind of a neat way to go with that one. Here's another example of a transition. And so this is in Portland, but I've got examples from other places too. And you're coming off of their sort of riverfront trail along the Willamette River through downtown. And you come up to this corner, and there's multiple ways you can go. You can get in different types of bike lanes. You can go this way in a bike lane. You can also go this way in a bike lane. And so they have this diagonal signal, which allows you to call the signal. and go in any direction. And so that's kind of a neat example of how to do that as well. And these are, again, only actuated if they're needed. And this brings up an interesting question, how do you model this? Because most of us use, most cities and other folks will use synchro to model their traffic. And what's bad about synchro is that it has to assume that this phase is going to be called every cycle in order for it to make sense to the software. So there's no way for you to say, oh, we're going to have 15 bikes an hour and you're going to call this every 5th cycle through that time. We can't do that. So the synchro model typically will tell you the worst case scenario, and then you have to use some level of judgment to say, okay, if this is only happening occasionally or once out of every so many cycles during the peak, what's that actually going to do to our performance? Because it'll probably be somewhere between the existing level of performance and the worst case that's being shown. But it's never going to be as bad as what synchro actually says. So neat little tidbit of information there. Here's another interesting one. This is from Los Angeles, and they have a point on Spring Street where their right side bike lane on a one-way transfers over to a left side, and they decided to use a crossover signal at this case. And I've seen this done in other places. There's one in Des Moines, Iowa, I think also, and I've seen them in other places, but this is what that looks like from an aerial. So you can see there's a detector in here, and you stop and you wait for the bike signal and you cross over and get in the bike lane going in the other direction. All right. And this is a use that I really like, and I don't see that many cities doing it. And let me set the stage to you on what we're looking at here. So this is a class 1 that's along a light rail line in Portland, and it has all these crossings. Most of the users that are using the class 1 are bicyclists. There's not, if you were to look at the counts, you would see probably, I don't know, a vast majority of them would be bicyclists. So you get to these intersections and you have an actuated set of signals. And so if you were to use the pedestrian crossing, you would have to use pedestrian clearance times through the whole thing. So 3.5 feet per second across the entire wide intersection. And so what the agency decided to do here was, let's have bicyclists call a specific bicycle signal, let them leave the class 1, go into a bicycle area, and then we can shorten the amount of stoppage that happens for other people to get the bicyclists through safely. So if you're a pedestrian, you can still come up, hit the button, and get your full clearance time. But if you're a bike, you come up, you get less clearance time because you're moving a lot faster. You're able to move faster than a pedestrian. So able to pick up some efficiency. So really neat kind of ITS way to look at reducing delay and having a safe crossing for bicyclists here. So kind of an interesting way here. Some of the restrictions that are in the interim approval are you basically have to have a bicycle facility. You can't do a bicycle shared lane. So you can't use a bicycle signal if you're coming from a shared lane with other vehicles, because who's it really going towards? And so even if you're using like a bike boulevard or something, what we'll do is we'll create a little waiting space that's exclusive for bikes, and that basically satisfies that condition of the restrictions, and then you can continue across the street or across the intersection. Another thing that interim approval says is that we can't use the bicycle signal with a hybrid beacon. So you can only use it with a traditional traffic signal, which means that you can't really do half signals as easy as you could with hybrid beacons. You have to do kind of full intersections. And that's why we'll see sometimes signals that have some type of turn restriction from the side streets, so that we're not creating a magnet to attract and focus more cut through traffic on this local street, that we're really trying to keep lower traffic for motorists and for bicyclists and pedestrians using it. Another thing that it says we can't do is have bicycle scrambles. So you can't just have bike lanes coming up on all sides and then have turns going in all directions during an exclusive bicycle signal phase. They say no. I tend to think that one's kind of playing it pretty conservative. I think most bicyclists are pretty savvy, and you're not going to see a bunch of bicycle T-bone collisions in the middle of an intersection during a bicycle signal, but that's just my thought. You also are not currently allowed to use a bicycle signal for a leading bicycle interval. So we can't use this to give bikes a head start out of the intersection to let them clear, which I think is unfortunate, because that is a interesting usage. And the reason that you can't do it is because that implies that there would be a permissive component of the signal phasing, hence violating the other condition, the main condition of interim approval 16, which is that you cannot have a conflicting motor vehicle movement with a bicycle signal. So that's an issue. The current guidance that's in the proposed rulemaking for the METCD for the next version does not include any allowance for a permissive leading bike interval. However, there have been FHWA experiments both in New York City and in Austin, Texas, that looked at dozens of intersections, and they used flashing yellow arrow and leading bike intervals and found pretty good compliance and pretty good safety out of that. So the nice thing there is you're not having quite as much of a delay implication to using the bike signal. You're getting some safety benefit, but you're not getting all of the penalty. So let's talk about some of those penalties that we get occurred to us with the bicycle signal. So one thing is that if you're trying to get an exclusive protected phase, we really can't make that really long and comfortable for bikes, because you're taking it away from time that could be used to move other users during that same amount of time. So if we can, we try to move non-conflicting movements with the bicycle signal, but you're going to reach a point where you have to start moving other users to get the signal to function. And what that results in is shorter green intervals for bicyclists. And so let's say you've got a larger intersection and you have 45 seconds allocated towards green to a single approach. Now for the bike, if you're using a bicycle signal and you've got a right turn only lane, maybe you're only getting 6 seconds of green out of that 45, so that you can then clear the bikes, turn off the bike signal, and allow those right turns to go through. And so from a bicycle perspective, you're getting a safe crossing, but you're probably going to have to wait to use it. Like 95% of you are probably going to have to wait to use it. And a lot of bicyclists will look over and they'll see the other adjacent parallel vehicle lanes moving, and they're being told they cannot enter the intersection. So that's not something that some bicyclists will enjoy, and some of them will be non-compliant with the traffic control device out there and enter the intersection. So those are problems. If you have a really busy intersection, they probably won't do that. They probably will be compliant with it. But if there are gaps, if there's a lighter flow of right turning vehicles, then they will be uncompliant with the signal. So that can be a problem. Another big problem is large intersections. So let's say you've got 120 feet to get across, and a lot of cases, because the change interval for bicyclists, the clearance time of it is somewhat short. There's still maybe time where you're entering the intersection and the bicycle signal will go yellow and you have to get across, but they can't just rest the bicycle signal on yellow for too long. There's like a 3-second fixed time for that. So then the bicycle signal goes red and you haven't even gotten halfway across the intersection yet. And you're seeing, as a bicyclist perspective, red light all the way as you're going. Now the signal is probably timed to allow you to do that. And there's going to be all red for the cars too that supports that. But it's uncomfortable for bicyclists at really large intersections because of that short yellow interval that gets built into it. Another problem is bicycle progression. If you're trying to have folks maintain momentum along a corridor, this will tend to chop it up and make it more difficult to do that. Again, squeezing more stuff out of a signal cycle is difficult in some cases. You may have an increase in vehicle delay, primarily for right turns, and in some cases left turns, I've found. So can your right turn strategy absorb that? And then the other big thing is, do you have this as a detection, or do you have it built into the cycle? And so some intersections I've seen will have this built in. Bicyclists get a short green interval as part of every cycle, whether they're there or not. I'm a big fan of technology in this standpoint. And typically what we'll do is we'll not only build in presence detection at the intersection, but we'll build in advanced detection leading up to it. And when you put in advanced detection, you're reducing the likelihood that as you pull up to the intersection, you just missed the detection zone window, and adjacent motor vehicles get a green, but you didn't trip the signal. So you're reducing the likelihood that happens to virtually nothing, and you're not going to be missing out on a whole nother cycle to get through. So those are all little techniques and tricks that we use to optimize our bikes at intersections. There's a picture on the screen right now of what we call a confirmation light, which is allowing you to know that, hey, the signal knows you're there, you're going to get served, because there is confusion with bicyclists a lot of time whether or not they've been detected at an intersection. This is a nice tool that helps them, and it has a benefit to increasing bicycles' compliance with the signal. So there are vendors that make these. There's other products on the market that have been sort of adapted to provide this type of use that have been studied in Portland. There's a whole paper on this that are out there that you can find if you're interested, or I can point you to it. We actually have a white paper on Alta's website that gets into bicycle signal detection. So if you're a super nerd like me and you want to get really into all of the current technology that's out there, there's a good summary of that, better than you'll find anywhere else, that goes into all of that information on our website. So any other questions on bicycle signals? Okay. Well, if you do have any questions, feel free to ask and we can return to those. All right, so let's move on to transit stops and bike facilities. And this is another question in terms of, we get asked a lot, how do you have high quality bike facilities and high quality transit facilities coexist on the same type of a roadway? And the problem really comes from progression. And what we find, this is what we call a time-space diagram, and it shows sort of the bicycle and the bus here moving along a corridor, and then the green and the red, which is what you're seeing, those are each intersections, and time is progressing on the x-axis and distance is progressing on the y-axis. And it shows kind of how you get held up by lights. And if you can get what we call progression, you're reducing the stopping and you're sort of coordinating all those signals so that when you arrive, you're hitting that green zone and you're able to clear through. And what we've noticed is that when you add in the dwell times for stops, you have a similar progression speed with a lot of roadways that have transit as bike. And what that does is it creates this leapfrogging effect, right? So bicyclists will come up on a bus while it's pulled off to the bus stop, have to figure out how to get around it. And then the bus passes them on the next block and then immediately pulls off the road again and blocks the bicyclists on the block after that. So you have this happening over and over again because they have similar speeds of progression along the corridor. And, most of the time, on our transit streets, we have what we call pull-out stops. And so the bus will leave the stream of traffic, pull over to the side of the road, and the bicycle lane will either be a part of that space because we may not have enough space to have it totally out of the stream of traffic, and then the bus is actually blocking the bike lane. In some cases, there might be enough space to partially have a bike lane clear the outside, but again, that's kind of sketchy from a bike perspective, right? Because you're buzzing by this bus that at any second is going to finish boarding and want to pull back out into traffic. And so that's not a comfortable, scenario. And there are a lot of bicycle bus crashes out there in a lot of our cities. There's other countries out there. I think I saw this in Sweden recently, but they took all their bus drivers and they basically had them experience bus stops as pedestrians and bicyclists, and they put them out there on a bike, and then another bus driver basically buzzed them and did all of these unsafe things that bicyclists typically feel. And that really gave them a common sense of, okay, this is how my operation impacts other roadway users going through there. But this is a common problem. And essentially what our industry has created is the best solution is to avoid the conflict completely. And that is to float the bus stop, get bicyclists around behind it so that they can traverse through here and not really be held up or impacted by the leapfrogging effect, which happens on the roadway. So this is showing a traditional class 2 bike lane coming into a transit stop, leaving. And so we're basically removing the bus from the pullout, creating a floating island. And there's some operational benefits here for buses as well, because they're no longer having to re-enter the traffic stream and get let back into traffic. They're owning that. We want to do things that they can use to reduce their dwell time. So fareless boarding, situations where you're not having a bunch of people put coins and dollar bills into a fare box at the front of the bus. And then it's just about discharging and boarding the lighting passengers, and off you go again. And so we're going to reduce the delay for everybody. We're going to make transit more competitive, and we're going to separate out bicyclists and transit conflicts at the intersection. So really awesome, works really well, reduces delay, improves safety. The conflicts between pedestrians and bicyclists are manageable. There's a great image or video out there on Vimeo that shows a image on Market Street in San Francisco, and one of their floating islands like this with a Muni train, and there's just hundreds of people getting off of that. There's bicycles filtering through, and everybody just figures it out. It's really beautiful in some ways. but it shows how this conflict can be negotiated really, really well. So here's, the bicyclists remerging into traffic, and these images were from the NACTO Transit Street Design Guide. Here's an example from Denver where they're doing the same thing, and here the bicyclists are merging back into their bike lane on the far side here. It's hard to see, but they're coming back in. I have dozens and dozens of pictures of floating transit stops in cities all over the country. So Jessica's asking, what about detectable surfaces between the sidewalk and the bikeway at the stop? Yes, and we want some type of delineation between the two. And so the picture that I have on screen here has a curb ramp here that's warning pedestrians, essentially. It's also got all these furnishings that are sort of corralling pedestrians over towards this crossing point. So it's not the best design I've ever seen, but it is trying to get in there. If I go back to the NACTO slide, there typically would be some type of separation here. There might be a railing that's here, and that would corral people towards the preferred crossing location. The Market Street example has nothing. It has a couple of delineated spots, but people are just hopping off the curb anywhere, and it seems to work, in that way. So I'm not sure if this has to do, if it has a high correlation with safety or just sort of order and organizing the types of conflicts that are there. I'm not completely sure on any type of data that would go along with that. My own personal viewpoint is that I don't think that pedestrians should have to change their grade to deal with the bike lane. I think raising the bicyclist up to the pedestrian level is nice because it sends the message that, hey, we're entering you up into this pedestrian zone and we're telling you that you need to yield to pedestrians if necessary. And I think that has a little bit different messaging than keeping the bike lane at street grade, which obviously would be a little easier for drainage and all that kind of stuff. But this has the feeling like the pedestrians are crossing a bike lane versus the bicyclists are crossing the pedestrian bus stop. So that's my own. I like subliminal messaging. I like little design cues that sort of breadcrumb the desired behavior to you in that way. And from the NACTO guide, also you could have a class 2. You could also just have a class 4, which just stays at the curb, and then the whole bus stop floats out in the parking lane, which is another really good way to do that. And here's an example of that from Chicago. Some really cool blocks that they've done with their BRT projects through downtown there. So the next question I'm going to get out of this is, well, what if we don't have enough space to actually have all of these different modes sort out in this way? What if we don't have enough space to have a sidewalk, a furnishing zone, a bike lane, and fit the transit stop all in the preferred widths that are there? And the NACTO guide weighs pretty heavily on experience from Toronto in Canada, which has a lot of bus and streetcar lines that basically discharge and board and alight their passengers right into the bike lane. And so they're keeping the bike lane from being blocked by the transit vehicle, but it's still in conflict with the pedestrians boarding and alighting. It's an interesting design. Here's a picture of what that looks like in reality from Toronto. And I've ridden through these, and they really aren't quite as sketchy as they might seem at first glance. And I wanted to take you through a project that we worked through a couple of years ago with Portland and their TriMet and their Metro kind of transit agency there, and trying to tackle this because we had a really long corridor. It's the Division BRT project, and we were trying to create a high quality bikeway and a high quality transit way along this street. So again, those are going to be goals that are very hard to kind of reconcile with each other, particularly when you don't have a ton of space. So we went through a huge variety of stop designs, some of which would bring the bike lane, let me clear all of this. Some of which would bring the bike lane all the way back and around the bus stop and all kinds of crazy things. And we actually sort of configured, as part of a public meeting, all of these designs using duct tape in a multi-purpose room in a school on the carpet. And we had people ride bikes and pretend like they were getting on and off, and we kind of troubleshooted some of the things. And what you see in the rendering here is kind of what we came up with as a desired guidance. And what's going on here is we have a step out zone, which is what we're calling, where you can get off the bus and not have to be immediately worried that you're going to get an unexpected conflict. So you can get off, step off, and see what's going on, and then cross. And we have a sign here that's telling bicyclists that they need to avoid conflicts with pedestrians. We're ramping the bicyclists up onto the platform. The wheelchair ramp at the front of the bus is actually using the bike lane as part of its platform area for that. And then we have 2 layers of domes. We have one on the platform because they're required by ADA, and then one that's delineating pedestrians, just letting them know that this is a slightly more. So we went through focus groups. We actually, the transit agency built it out of plywood and used kind of, this is like roofing tar paper here that they stapled to it. And then they did a bunch of trials with their BRT buses and volunteers and troubleshot that a little bit more. And then all of that transitioned into a built stop. And so this is the final product. This just opened earlier this month for full fare service. And so far, haven't heard any negatives about it, but it was a pretty neat public process to kind of push the needle a little bit further with regard to bus stop platforms and transit. Any common problems any of you are running into, or any of you trying to solve this type of a problem in your community? Be curious. All right. Okay, so one other thing we wanted to cover was the concept of streetscape amenities, bicycle parking, other types of facilities. And you know, I think California in general has been a leader in this across the country. And so I'm not totally sure on what components of this we need to talk about, but I did want to sort of cover what short and long-term parking are. And short-term bicycle parking is stuff basically that you're expected to kind of have a place to leave your bike for a few hours. You know, this wouldn't necessarily, it could be an all-day thing, but generally the guidance out there says that this is not meant to be an all-day commuter type parking spot, and it's something that is an accoutrement to the streetscape. It could be banks of parking that are like the center image here that's oriented towards a single land use. It could be sprinkled throughout an area where you might have bicycle activity and a number of destinations that you want to get to. It could be architectural, it could be artistic, it could be built into the streetscape furnishings that are there. So there's a lot of different designs that are out there. I would say that the examples over here, this wave rack is not really considered best practice. Basically, you want 2 points of contact between the bicycle and the rack, and that way the bicycle doesn't rotate and fall over due to the lack of support. And then you also want to have an easy way to use any type of bike lock to secure both the front wheel and the frame of the bicycle to the rack. And so those are 2 criteria which basically push us towards a couple of more ideal designs. And you can see these over on the left here. So this is called a post and loop rack. And this actually, this loop provides additional points of contact to both lock to, but also to support the frame. And then this one obviously would be pretty easy to lean your bike up against and lock to it over here as well. So those are all things that we look for. This one is a little bit interesting. It supports the wheel a little bit, but also supports the frame up here. And then it has a locking area that you can lock to in this area. So this is kind of okay, but I would probably go with what we call the staple or the inverted U or the post and loop. Those are my favorite just because they tend to be the easiest to figure out how to use. Sometimes we'll have public art that people lock their bikes to, and sometimes people won't lock their bikes to the bike rack because they think it's public art. There's just a bunch of difficulty in figuring that out sometimes. But here's short-term parking, and that can be, you know, behind the curb. It can also be in the street. And I love these in-street bike corrals. We're seeing them a lot for scooters, bicycle share, just general bike parking. When I was in undergraduate civil engineering, I did a class project once. We had in San Luis Obispo, where I was going to Cal Poly, we had one of the first bike corrals in the state, and it was in front of this coffee shop that I love to go to. So I did an informal survey, and I counted on the street that the coffee shop was on what the vehicle occupancy and the parking turnover rate was for every parking space on that short block, and then also calculated how many people came and went from the bicycle racks. And the bike rack per square foot outperformed by a factor of like 13-1 over the rest of the parking spaces in terms of the wallets that it was delivering to that curbside. So good things to intersperse. And the nice thing is that you can park a lot of bikes in an area that are not now going to be blocking and mucking up the sidewalk, because you've probably seen a lot of cases where you do have a lot of bikes, they're locked to trees, they're locked to, I mean, even when they're locking to bike racks, if there's not enough bike racks, that can be a problem. So having on-street corrals is a good thing. And both of these are in the peninsula here as well. One of them is Palo Alto. I don't know where the other one is. Palo Alto is the one with green on the left. Okay, so that's short-term parking. And then let me, before I go into long-term parking, hopefully your cities all have, thank you, Patrick. San Mateo is the one on the right. Hopefully you all have some level of bicycle parking requirements built into your code. And typically what this looks like is I've seen it done two ways. Either it can be totally separately addressed, or it can be basically bolted onto the vehicle parking requirements that are already in there. And so I love having them in the same place because it puts the same level of importance on them. But what we see typically is about 10% of the vehicle spaces would be minimum would be provided as bicycle spaces for any development project. There's different things that you can do for multifamily residential versus single family residential versus commercial, and it can be based on square foot, it can be based on floor area ratios, it can be based on just number of companion to the number of vehicle parking spaces that are already required for those land uses. So there's different things you can do there. There are a lot of communities have put in exceptions where if you provide more bike parking or different types of bicycle parking, particularly secure or long-term bike parking, which I'll show you some photos of in a second, those can be basically ways to remove some of the burden of providing vehicle spaces because of the extra benefit that you're getting out of the non-vehicle spaces. So from a developer standpoint, that can be really attractive. You can reduce the number of vehicle spaces that you're required to provide by providing better bicycle parking. And long-term is the other type of bike parking, and this is where we have a space that's typically protected and sheltered, and it's an area that you would be comfortable leaving a bicycle for an entire day or longer. If you're going to work, if you're commuting, if you're in a residence or a multifamily type housing situation, you want that long-term, more secure type of bike parking. And this can be done in a number of ways. Typically, there's either a locking mechanism or some type of key card or other type of limited access to those areas. And they can be very effective at making, particularly if you're going to be a daily longer term commuter, you might have a nicer bike. You might not want to leave your bike out where people can mess with it. You want to have it protected or just only accessible to other people that are riding and you. So there's a lot of things that can be done with that. These are both examples in San Mateo County as well. At transit stops, I think one's at a Caltrain. Not sure where the other one is. Looks like it's near the marina somewhere. And then, longer term bike parking storage in parts of, this, I think the one on the left here is from a campus environment. So they have this big cage that's key card or code oriented. So you only have access to that cage if you're a subscriber to that area. The one on the right is a secure bicycle room. And this would be in a building or in a transit stop or something. And you would gain access to this through a subscription. And then you have these really, convenient, easy to use racks at those locations. So these are all going to promote bicycle use. If any of you have ever seen some of the bike parking that goes on in Europe, in some cases, they have, underground parking garages with thousands of spaces and ride in, ride out, bicycle shop built into it. It's really incredible kind of what can be done out there in the world, and we're starting to see the benefits of moving in that direction in some ways. Jessica's asking, any examples of bike rooms that serve building tenants and the public? I know that there are some where you can sell memberships to, but the person basically, the individual that wants to use the bike room kind of has to know where to go to find that information. And so you could sell a membership to somebody outside of that local room. I've seen that done in some areas. There's also what I would call part of like a mobility hub or something. So a major mobility hub, which is a concept that's starting to expand. So where you have intersections of different modes, whether it be transit, ride sharing, Uber, Lyft type things, bicycle share, scooter share, long short-term bicycle parking, transit oriented or person oriented services that might be all in that area. There could be, if you've ever heard of bike stations, I know Berkeley has some bike stations, I think, where it's a private enterprise, but it's there to basically provide that service. And so there might be showers, there might be secure bike parking, coffee shops, all kinds of stuff built in to do that. And those would be good examples of precedents of being able to serve the public and a private audience as well. Major transit stops will often have their own program where you can subscribe and get a secure area. I'm thinking back, I mean, I've lived in places in larger cities that have had secure bike parking in my building. And that was, obviously primarily just for the residents that were there. And it was very helpful. Meant you didn't have to have a garage or, some other type of space there, but not exactly sure. I mean, Patrick or anyone else, if you know of any examples around the county that might meet Jessica's query, feel free to throw it in there. Yeah, thank you. There's the Berkeley link. So really
yeah,
neat
that was
facility.
built as part of a parking garage.
So yeah, and I'm sure that parking garage could have been also there to meet like the local need for whatever that was generating the use for, but it's also publicly available to anyone that wants to subscribe. So that would meet that criteria then. Okay. All right. Last thing that we're going to go through is bicycle boulevards. And then Patrick's going to talk about funding, and then we'll be able to wrap up. And we probably won't need the entire last hour. But before we do that, I think it might probably make sense to take another 10-minute break. So let's do that, and then we'll come back and talk about bike boulevards. So we will be back at 1:10. That sounds good. We'll be back in about 2 minutes, maybe a little bit more than that. 2 minutes. All right, we're going to get going again, and we're going to talk about class 3 shared routes, but mostly under the lens of bicycle boulevards. And yeah, sorry if there was any confusion. I was reading the timer on the clock of the presentation, not the actual time of day. So we're back. All right, so class 3s. Great bones throughout a lot of the communities that we have in the peninsula due to the grid pattern that exists in most of the built up areas. So here's a map from Palo Alto kind of showing a lot of their local streets that can be improved into bicycle boulevards. They've got a pretty good corridor network there. I've been involved in elevating several of those corridors to full bicycle boulevard status. Berkeley also has a really good network, and then Redwood City, Mountain View, and some others have been putting them in as well. So if you haven't gotten on the bandwagon yet, really great facility type. The nice thing is that they use the local streets primarily, which are about 60% of our roadway network. And they also just are places, we showed all of the LTS maps at the beginning of the training today, and you saw all the green lines along residential streets. Those are comfortable for most people. And so we can leverage that and make them into prioritized routes across our communities. In some cases, in addition to or in parallel with some of the larger corridors that we're doing more things to, but this offers a kind of almost a alternative network for people to use to get around the community. And the question that I have here for the chat window is, what produces the most level of discomfort for bicyclists in a shared roadway environment? Like, what specific thing do people feel when they're riding on the street? Anyone in the chat box? Hopefully we've got everyone back from break here. We call on Jessica, but I know she's here. So who else can I call on? Let's see here. How about Elizabeth, Grace, Andrew? We've got 3 Andrews. One of you must be here. Speed of vehicles. So sharing and so we've got a few different speeds. So Chandra is saying shared space passing by higher speed vehicle. And I think, Chandra, you hit the nail on the head with what I was looking for, which is passing. Like people are very much concerned by the number of times that large vehicle moves out of your blind spot behind you and goes around you. And so that is an uncomfortable maneuver. And the more times that maneuver happens, the less comfortable that facility is going to be. So, we can have a shared lane marking put on an arterial roadway with a 5-lane cross section. That exists in a lot of communities around the state, but is there a lot of passing there? Is that passing happen at higher speeds? So those are frequency things that make it very uncomfortable. So we learned really quickly after the shared lane marking got in the METCD that maybe our major road network wasn't the right place for that. And maybe some of these lower volume, lower speed areas are really where we want to have that marking, because we can create a sense of comfort, and we have a innately lower level of conflict with the number of passing cars, and we can do other things to further work on that. So that's what a bicycle boulevard is, and that is one of many different names that we have for that type of facility type. We're working on network in Virginia called neighborways. The one in Fort Collins just calls them low stress routes. Neighborhood greenways in Portland and Seattle. I've heard quiet streets. We're doing quiet street network right now in Atlanta. So there's a lot of different places that have different words for what we're trying to accomplish. But what we're trying to accomplish is to leverage the good qualities of a local street, prevent them from getting worse, and enhance them and make it a place that people can really get from point to point throughout their community. And there's a few things that we need to do to really leverage that, because a lot of folks, once you get off the major roadways, you don't really know where you are. We're not used to navigating throughout our entire communities on local streets. And so we need wayfinding. We need branding that tells us that we're on that network. We want to have that confidence. We need to be able to think about what happens when we get to a major street crossing, because a lot of times the local streets don't have any traffic control at those locations. So we need to be thinking about what we can do to make it comfortable and safe for people to get across the street without attracting more motor traffic to that area that's going to degrade the benefits that we've already gained. So these are the three kind of categories that we're going to talk about today. We're going to talk about traffic compatibility, what we can do to reduce the number of vehicles and the number of passing opportunities that happen. We're going to talk about getting across the major streets. And then we're also going to talk about what we can do from a look and feel perspective to brand and make that corridor a really beneficial one. So from a volume standpoint, there's two things that we can do, or a passing standpoint. So if we want to reduce the number of times you get passed, the first thing that we can do is make sure that folks are traveling more slowly. So if we go from 20 miles an hour to 30 miles an hour, even if we keep the speed or keep the number of cars on the roadway exactly the same, we'll have 50% more passing going on a 30 mile an hour road than a 20 mile an hour road. That's just basic, arithmetic at that point. So it is important to keep that speed low, both from a safety perspective, but also because it lowers the speed differential between bikes and cars, and you'll have fewer passing and overtaking maneuvers. So really good. And we can keep speeds low either naturally through the built environment of the roadway, or maybe we need to do something to the road. And so we could do a vertical or a horizontal speed management type of a situation. 20 miles an hour is the preferred posted speed for a bicycle boulevard type facility. It just is a lot safer than others. In Europe, they use 30 kilometers an hour, which is about 18.5 miles an hour. So it's pretty close to that 20. So that's where we're shooting for right now. There's been places that have passed, sort of local resolutions to allow 20 mile an hour streets. Some places are just doing it. In some cases, there's had to be a state law passed to allow 20 mile an hour posting, but it could be a special designation for your bicycle boulevard network. It could be something that's already in your toolkit that you can just grab. But that may be something that you need to think about in order to get that lower speed limit posted. Horizontal traffic calming is basically creating, side friction for cars as you go along the roadway. And that could be in the form of a neighborhood traffic circle at an intersection. I love using neighborhood traffic circles for junctions of two bicycle boulevards, curb extensions to shorten up crossing distance for pedestrians and to add that side friction, chicanes, pinch points. We've also seen some really cool painted intersections and murals done on the street, which just kind of generally brings things down to a more human scale. So there's a lot of things that we can do from a traffic perspective on horizontal. And then vertically, we can raise people up. And so, if you have to go over a speed bump or a depression, a negative speed hump in a street, that can slow you down. Also providing, raised intersections. The one on the right is, we did two raised sort of dogleg intersections in Palo Alto. They had different designs, but this one's a raised area for pedestrians and cars and bikes all to share. So that can be a way to slow you down. But again, that's a pretty big improvement type to get to work there. And then from a volume management side of things, we can reduce the number of passing opportunities just by reducing the amount of traffic, right? So if we go from a street that has 5,000 vehicles a day to one that has 1,000, we're seeing a 400% change in the number of cars that are likely to pass you on your way somewhere. So this can be done in a lot of different ways. It can be done just by making it a little bit harder to get through, which actually a lot of times the locals will really appreciate that live there. We can create, sometimes just the traffic calming will depress traffic a little bit, but in some cases we do need to do a little bit more, and I'll go through some examples of that. And that ranges really from a full closure, and that can be closing off the end of a street. The bottom image is in San Luis Obispo. This is the Morro Street Bike Boulevard, and they basically closed a leg of an intersection here and allowed it to be permeable for bikes going through. So that's kind of a really great way to get downtown from a major class 1 that's coming in from the east of town. There could be a partial closure. So this is kind of, you can get out of the neighborhood, but you can't get in, except if you're a bike, then you can go both ways. A couple examples of that. You need to have enough width to be able to get fire trucks through. I think we're working on one of these right now in one of the South Bay communities near a mall. We were working on some design last year for that. So I don't know how far that's going ahead, but something that we're thinking about. You got to make sure that that fire trucks can go in both directions through something like this at all times. But yeah, that can work really, really well. Diverters, a couple of diverters exist. There's some of them in Berkeley that are sort of, you angle the road in a 90-degree in both directions, but have a permeable corner for bikes to get through. And this prevents enables good neighborhood circulation, but it prevents people from using that route as a through route, except if you're on a bicycle or on foot. And so that can work really well. And the ones in Berkeley are really nice because they have a lot of vegetation and they're very well planted and look really great. So that can be done in other places. And then, at intersections, we can also, particularly signalized intersections, we can do things where we're diverting traffic. And I showed that example from Fort Collins earlier. Here's two that are closer to home. Palo Alto has some. The bottom one's Redwood City. I think we worked on this one. And then Berkeley, which has been one that's been around for a really long time. I think I took that picture in 2003. So that one's been there that was kind of the original forced diverter intersection. But a lot of communities around the country have adopted this. It works really well. It allows you to have signalization, get bicyclists through, but block this as a cut through for motorists. And a lot of times, if you have a good grid, you can just, if you have any issues in the public involvement side of things and getting this installed, as long as there's good connectivity, you can just show them, hey, you just need to go a block, upstream or downstream, and you can make your left turn there or go across. And those are areas that it's pretty easy to do. So we were able to message that in other projects, and the public was pretty accepting and got what we were trying to do and enjoys the new signal that's there that enables people on foot and bike to cross a busy street. So those are all things that work really well. Next thing, any comments on intersection treatments? There's just so much here. There's protected corners, there's rapid flash beacon crossings, there are pedestrian hybrid beacons that have been used really well in Tucson and other areas that enable bicyclists to get across the road. So there's a lot of innovation here, and these are really fun projects to work on because they really make you think really carefully. There's a lot of creativity that goes into the design, not creativity in a way that's breaking any rules, but just creativity in the way that you're approaching how you're applying the standards that exist. So those are all things that I've really enjoyed working on these type of projects. I'm excited about some upcoming ones that we're about to dive into on this. Any other questions on forced turns? Okay. Another thing I wanted to cover was what we call bicycle momentum. And this is a really interesting concept. And what it essentially gets down to is if we can keep people moving on bikes, we're going to drastically lower both the amount of travel time that they need to get from point A to point B, which will make bicycling more competitive, but also we're reducing the amount of energy that somebody has to expend as a bicyclist to get from point A to point B. So for example, if you have a stop sign every other block, you're not only going to have to lose the time in slowing down, stopping, and then going forward again, but your body no longer has to supply the additional energy to get yourself moving again and get up to speed back to what you were. And so both of those things are good. Again, your travel time is much lower on streets without frequent stop signs. So if you can get away with other types of traffic control, yields instead of stops, for example, two-way yields, I really like. I wish, honestly, we have so many unwarranted stop signs throughout our country. Unless there's, really a visual problem with doing a two-way yield, I would go with those. And then you could use things like neighborhood traffic circles also to provide a yield environment without having to require people to stop. So there's a lot of things that can be done there. And then your stop sign spacing as well. And then finally, we can look at things from the types of intersection control that we have also, which can help minimize delay. So if you're trying to cross a 3-lane roadway, for example, that has good gaps, you don't need a full signal there. You don't have to stop people and make them wait. They can probably find a gap and get across pretty easily. So are there things that we can do with rapid flash beacons or other types of devices to add that comfort, improve the safety, and still get people from point A to point B quicker and reducing their delay and increase their travel time, or increase their speed as they're moving through. So those are all things that we can be thinking about. And then I had this question, just added this in last week, but just a question of, are bike boulevards compatible with the full range of 8 to 80, particularly with the younger end of folks? Can we use these to get to school? And I guess my answer here is it depends. I would say that it's more critical to have a facility that has fewer vehicles traveling more slowly on a route that you might be prioritizing as a school route than it might be for a general type of a bicycle boulevard. Now, when bike boulevards came out, there was sort of a threshold of about 3,000 vehicles a day for when you would consider, so 25 miles an hour, 3,000 was what most people said was comfortable. We've since that standard still exists, or that guideline still exists, but what we found is that a lot of communities have reduced. They've gone to 1,500 or even 1,200 vehicles a day in some cases, and trying to get less than 20-mile-an-hour speeds. And I think if you hit that, yes, it can be fairly compatible with a wide variety of ability levels. The photo that I have on screen right now is from a bicycle boulevard in San Luis Obispo, California, where I used to live. But one of my first jobs there was I was the MPO level sort of safety person. I would go actually into the schools and we'd do traffic safety assemblies. We would lead them on bicycle rides to learn how to operate bicycles, go through a bunch of skills tests, all kinds of things like that. And out of this, developed a pretty cool Safe Routes to School program within the city, and different schools adopted it at a different level. But I'm still really good friends with an old friend of mine that has a son that goes to, or he's now in high school, but when he was younger, he went to one of these elementary schools. And so I sent her a note and I said, hey, do you have any pictures of the bike trains that y'all used to do? And so a bicycle train is a supervising adult which meets and collects kids at one point and then leads them through the corridor and gets them to school safely. And so that can be called a walking school bus if it's pedestrian activity, but it's also called a bicycle train. And so this is an average everyday morning. I think they had organized one several days a week, and they had a different parent volunteer do those. And so those could be really interesting programs to get moving. I've also seen in some cases routes that have a priority for schools that might have a slightly different type of engineering attention devoted to it. So things like a hybrid beacon installed where you might not do it otherwise, but you're doing it in a place where you don't have to have a crossing guard, and you're going to get that positive stopping activity that you want to create amongst motorists. So, certain things that could be enhanced along that corridor to make it compatible with Safe Routes to School opportunities. So I would say that about child compatibility. So if there's any other ideas anyone has or wants to talk about that anymore, I'd be happy to go into that. I mentioned major street crossings. I think I forgot that I had these other images, but these are much larger roadways. And again, you can have a gamut of running from the one on the right here has just a push button that you can get to from just the side of the road. And that creates a rapid flash beacon to cross the road. And in Portland, they have very good compliance with rapid flash beacons. There's a little bit of a gray area, and does the bicyclist have the right, have right of way over moving traffic? And the way that this is configured, you could argue no, but the city says, look, it works so well, we're not going to worry about it. Some projects that I've been involved in, I'm going to move forward and then I'll go back. This is one that we built in Fort Collins, and we're using an RFB here too, but we created this little protected corner on both sides. So you can see the plan view here. So you come in on it and you hit the button. And what we're doing by getting you behind the curb is we're basically inferring the rights of a pedestrian onto the bicyclist, and we're removing the ambiguity around, do you have the right to have traffic stop for you by doing that? So that's kind of an interesting workaround. We've also seen bulb outs that we've had little ramps that bikes can get up onto and then use the regular crosswalk to get across, but this has a neat set of circumstances, and this has been very well received. We did our first one and everyone loved it so much that all future projects have had a similar design since then. So I think there's been about 6 or 7 that have been built just in the last 18 months using this type of a design. Now moving back here on the left, this is Palo Alto, also a big crossing, and this is using that right turn diversion again, similar to what we saw earlier, but on a larger intersection. So this is a full signal. And then a couple other examples. This is one that we did in Wichita, Kansas, and this was a 7-lane road that we were trying to do a bicycle boulevard to connect between a bunch of schools. And so we just decided to close the median, and we put a hybrid beacon here. And we have a little, it's easier to see over here, but there's a ramp that you get up onto the sidewalk, and then you cross through a gap in the median. You can see that line of path right through here. And while this is active, there's a blank out sign that illuminates. It's right here. It's hard to see, but it tells vehicles they can't turn right while the beacon is active. So again, very well received. And then this one is in Mountain View. And this was a bike boulevard that we were working on, and it had sort of an offset intersection. There was already a raised median here with no connectivity. There's a cul-de-sac that's right here that was blocked off from access to the road at some point. And so we added a little class 1 section of trail that got you to the roadway, had a crossing, and then added a section of kind of pedestrian cut through in the median, and then brought you to a little right in, right out island that you could then kind of filter back into the street. And so this is a really cool project here, and this has rapid flashing beacons on each leg independently of the side. You can see those right here. These are solar. So a lot of creativity gets brought into these projects, really fun. So go through. So what street is this in Mountain View? This is Jewel or Victory Avenue. And I forgot the. If you look for Victory Avenue, you'll come to this. I'm sorry, I can't remember. I want to say like Jewel Place, but that may be a different one. And then the other one, I think, can't remember. Sorry. Okay, so moving on to branding and wayfinding, and this is another thing to do and to be thinking about with your bike boulevard network. And so it's one thing to create safe crossings and to make a safe roadway, but if people can't figure out how to get from point A to point B, it's not really good for all that much. So we've seen a huge variety in wayfinding systems, in pavement markings, in branding along the way, everything from little accents that go along with the bike boulevards. It tells you that if you see this, you're on the route, to just doing different types of street signs. So in these cases here in the middle, this is actually Berkeley here, right here. And if you're on the bike boulevard, you have a purple bike or a sign with a family bicycling. And if you're on the non-bike boulevard, you've got a green street sign. Some of them will have just bicycle symbols on the street sign. This one's got a really nice, I think this is Madison, Wisconsin here. We've got that. So there's branding that goes along with it. There should be wayfinding signage that goes along with this, where you have destination signs that you can see what's coming up and whether you need to turn to get to a certain location. So how do you find the library, elementary schools, parks, central business district shopping areas, universities? There's a really common list of different types of destinations that you would put on those types of signage. So it can be a little bit of a project to kind of get to the point where you have this toolkit of what to use, which is an interesting project in and of itself, but you typically have to have that ready to go before you use the tools on the bike boulevard itself. And then markings themselves, you know, I showed the image of Palo Alto and Berkeley that have the really big full lane width wide bicycle boulevard pavement stencils. A lot of cities using just the shared lane markings are a little easier to use. This example is from Seattle, where they're showing kind of one marking with arrows in both directions at corners. Sometimes if you have to take a turn, this one shows kind of the arrows angling you towards, this is an entrance to a class 1 right here. So it's kind of neat, the variety of things that you can do with some of this stuff. This one would be technically not looked favorably upon by the FHWA because they think that this is a lane positioning device. And if you turn it into a wayfinding device, that is two things at the same time, and smoke will start pouring out of your ears, and you know, galactic paradoxes will occur and all kinds of things. But in reality, people get it. And the FHWA has experimented with wayfinding markings and haven't found as good of just legibility as just using the shared lane markings for that. So I'm in full support of using the markings to help overcome changes in direction, other types of issues out there that are like that. So yeah. Any other questions on, Patrick, I'm giving you a few minutes warning here, but any other questions on any of these topics of bicycle facilities? I'd be happy to keep monitoring the chat window. I'm going to hand it over to Patrick now, and he's going to talk about funding in San Mateo County and how you can get money to build all this stuff. So I will run the slides for you, Patrick.
Great, thanks, Joe. All right, let's go to the next slide. So most of you should hopefully know, I'm Patrick Gilster, the Manager of Programming and Monitoring with the San Mateo County Transportation Authority. I run our Bike and Ped program and our host of our other programs and work intricately with HIPAA to help with all of our programs. So big picture where we are right now in looking at different types of federal funding. Most of you are aware that the RAISE grants were just due. Infra is out now, and MTC has a whole process around most of that and the mega projects. And then at the state level, we're coming up on the active transportation program that will be released here shortly. You should hopefully have received some information from CCAG and from MTC about that. If you have questions about that, feel free to reach out. I'm happy to connect you with folks as well. We also have the Highway Safety Improvement Program and the Local Partnership Program. So the Local Partnership Program, sales tax agencies like CCAG and the TA, we get a discretionary portion, and there is a competitive portion. So any agency that is interested in the competitive portion of that needs to make sure to coordinate with the TA or CCAG to do that. I know when those get closer to coming out, we will put out a kind of call for interest in that program to help support applications for that as well. And then looking a little bit lower down at our regional and countywide level, we have both the Measure A and Measure W sales taxes that the TA manages, Measure M from CCAG, they just updated their strategic plan for that. And then the MTC One Bay Area grants, which will be coming out soon too. I believe there was a survey interest from CCAG about that, and will be more to come on that as well. And then at the end of the CCAG Comprehensive Bicycle Pedestrian Plan that was adopted last year, there is a long list of many different levels of state and local funding sources as well, if you're ever interested in that. And I'm always available to chat about how to fund projects as well. Next slide. So how is the TA incorporating all these things that we've been talking about, both at the larger Complete Streets webinar and the two kind of more technical trainings, the pedestrian safety training and the bicycle design training? On the highway side, Measure W does allow us to fund pedestrian and bicycle projects along and across the highway system. And then similarly, projects of countywide significance are being really re-evaluated to include more multimodal elements. So some of the projects that the TA and CCAG are co-sponsoring, we're really making sure we are holistically looking at those projects and that we're aligning both with our own scoring criteria for many of our measures and for the new state measures as well that are incorporating things like the Climate Action Plan for Transportation Infrastructure. And then taking a look at our bicycle and pedestrian program, we will be looking at how to prioritize quick build projects in our small capital projects category. We are aligning ourselves with MTC and CCAG in that we are limiting what types of class 3 bike routes can be funded. So looking more at what Joe was presenting today, really more towards those projects that are incorporating traffic calming, speed management, those other features that really make a more neighborhood route bike boulevard rather than just adding signage to the side of the street. So we're really looking at projects that to invest in that both have a safety and comfort level component. And then we'll really be looking at how jurisdictions will show that bike projects are improving comfort levels. So we'll be trying to help provide some easy ways to do that when we get to the next call for projects this fall. And then we'll also be looking at giving some extra readiness points and bonus points for jurisdictions that had staff attend these technical trainings as well. So we have been marking down who has been attending and want to thank you all again for that as well, and hope you are getting some good knowledge out of this. Next slide. So the most immediate funding source that the TA has, this January, we adopted our first ever alternative congestion relief and transportation demand management plan that is helping to guide our, I know it's a long name, our ACR TDM program. So 1% of Measure A and 1% of Measure W goes to fund this program. Our call for projects is out now with applications due in May. Some examples of bike projects that could be included in this are really anything that's enhancing crossing treatments and detection, can help apply in our ITS category. Short-term, long-term bicycle parking, mobility hub planning, e-bike subsidies, bike and scooter share subsidies. I'll also echo what Joe was saying about wayfinding. So wayfinding plans are eligible, and the wayfinding purchases are eligible under the actual competitive category as well. Bike parking plans are actually an eligible category or an eligible thing too. So if you need help with standards, evaluation of where you have bike parking and where there should be bike parking. So I know Joe showed a lot of different options in there. So there's different ways you can plan for that as well and purchase bike parking through the competitive side of ACR TDM as well. So this is really looking at how we're filling those mobility gaps that some of our larger programs, like our bigger bike and ped program, that might not be able to do, since some of these things don't have as high of a VMT reduction impact or something like that, that often gets funded through those big projects categories. And one thing I'll note on here too, our small and coastal jurisdictions have a set aside from the mid and large jurisdictions. You'll be competing against jurisdictions of your own size. And then we'll be looking to fund both planning and ITS and design as well. If you have questions about that or want to talk about ideas, please don't hesitate to reach out to me. There are mandatory meetings with TA staff, myself and my colleague Jennifer Williams, to determine eligibility and make sure you have a monitoring strategy. So feel free to reach out for that as well. Next slide. And then really exciting this year, we'll be releasing our next cycle for the bicycle and pedestrian program with the infusion of Measure W. This will be our largest bike and ped cycle ever. In total, we're looking at almost $18 million of money that we have just to spend here in San Mateo County. It'll be almost 16.7 million of capital funds. So both for large projects, those over $1 million, and then capital small, which is projects under $1 million. We'll also have some extra money in our planning and promotions category that are the carryover from the last round, which is exciting as well. And then we are giving a dedication to Safe Routes to School through the Measure W component, which is almost double what we were able to provide in the last cycle, which is very exciting. Some projects that can be funded on the planning side of this, or the planning promotions category, are any contributions to bicycle plans, corridor improvement plans, intersection and crossing studies. So some of those things like Joe was talking about of where those bicycle boulevard crossings are and how to plan for and identify what's good for those. You could do a whole study and design of those themselves before you go to the next level for actual construction funds. Any type of vision zero analysis or high injury network is also able to be used for that as well. And then example of capital projects, quick build, bicycle project, road diet or reconfigurations, protected intersections. And I also want to mention too on the thinking of sometimes intersection projects could be projects in and of themselves. So if you need help with those as well, or want ideas of where to fix those really kind of pinch points in some of your networks, that would be a good way to potentially do some smaller projects as well. And like I said, if you have any questions or ideas or want to chat about that, please don't hesitate to reach out to us. Next slide. And so my contact information is at the bottom, as well as Hiba's. Feel free to email either of us if you have questions. And I want to extend a big thank you to Joe Gilpin from Alta to helping create these presentations and take us through all of these, the bicycle pedestrian trainings and the Complete Streets webinar. And we really want to thank each and every one of you for attending today, as well as the other presentations. One thing we'd be interested in too, if you have any other ideas of things you would be interested in for future trainings, please don't hesitate to drop those in the chat as well, or email us as well. We can also stick around for a few minutes if you have any questions too, or want to chat about anything too. So thank you, Joe, again, and thank you all, and hope you all have a good rest of your day.
And Patrick, there's a question that just came in that might be something that you could answer.
Yeah. Oh, yeah. If no federal funding is already programmed, Caltrans won't agree to the approving agency for NEPA. How can we move our bike ahead forward toward discretionary federal funds programs so that they have NEPA clearance? I believe Caltrans does a DEAR process for that, or a peer process for that, for reviewing those and getting them to that stage. Most of our projects should be exempt. I know that's being extended, hopefully, knock on wood. But there are other ways that we can help with that as well in certain cases. So Hanya, feel free to reach out. I think you have my email too. We can help kind of figure out who at Caltrans to connect with about what you need to do.
I'm happy to stay on for a few minutes if anyone has any other questions, but if not, we'll release you with a few minutes to spare back to your